to please take your seat in the auditorium. Please settle down. Kind attention, everyone. Our chief guests have already arrived. We request you all to please take your seat in the auditorium.
So exchange is happening in their presence. So may I go and stand ahead?
And we'll be invited. We request everyone to convene at Zorawar Hall. आज का कार्यक्रम शुरू करने से पहले मैं उपस्थित सभी लोगों से विनम्रतापूर्वक अनुरोध करती हूं कि कृपया अपना मोबाइल साइलेंट पे रख दें। We request everyone to kindly put your mobile in silent mode. Dear all, it's a beautiful morning. It will be nice to have beautiful smile on your faces as we start the program. We request our C-DACians to please assemble at the Zorawar Hall for the inaugural session. Dignitaries have already arrived. We request everyone to please settle down fast and kindly keep your mobile in the silent mode. We request everyone to kindly occupy the vacant seats from the front. We request everyone to please fill the vacant seats in the front. There's a lot of space. Eventually, we can start moving backwards when the seats are full. Please occupy the front seats. First and second row are reserved for the guests. Thank you so much for cooperating. Just a little bit more. Please settle down fast. Please settle down fast. Please keep your mobiles on silent mode. And please wear a beautiful smile on your face. Thank you so much for cooperating, ladies and gentlemen. Request everyone to kindly take your seats. We'll be starting the event soon. Yeah. So I recently got this news. Sir is arriving in 2 to 3 minutes. Dear all, please occupy the seats, occupy the front seats. Please don't keep it vacant. Keep your mobiles in silent mode and a beautiful smile in your face. We are starting in 2 to 3 minutes. Thank you for being a wonderful audience. Thank you so much. दोस्तों कहते हैं खूबसूरत से एक पल का किस्सा बन जाता है, न जाने कौन कब जिंदगी का हिस्सा बन जाता है। कुछ लोग जिंदगी में ऐसे मिलते हैं जिनसे कभी ना टूटने वाला रिश्ता बन जाता है। आदर, अभिनंदन, आभार, नमस्ते, आदाब, सत श्री अकाल। A warm welcome to our wonderful, beautiful, and auspicious day where we celebrate our achievements and commitments to technology excellence. I'm Dr. Anandita and I'm thrilled to be here today. Joining me is Mr. Raymond Pinto. It is with great pleasure and honor we welcome our guests to the dais. आप सभी से निवेदन है कि करतल ध्वनि से इनका स्वागत करें। श्री ई मगेश सर, डायरेक्टर जनरल C-DAC and CMET, Dr. P. Hanumanth Rao sir, DG Sameer, Shri S. Krishnan sir, IAS, Secretary MeitY, Shri Amitesh Kumar Sinha, IRAS, Additional Secretary MeitY, Srimati Sunita Verma Madam, Group Coordinator, R&D in Electronics, IT and CCNBT, Shri Rajesh Singh, JSNFA, Ministry of Electronics and Information Technology, Dr. Suraj Rangarajan, MD Applied Materials, Professor Rajiv Ahuja, Director, IIT Ropar. We are truly grateful for your presence and for making this event a success. Now, to welcome and to show honor and to show integrity, we now request Shri E. Magesh sir, Director General C-DAC and CMET, to deliver the welcome address. Shri E. Magesh, Director General C-DAC, is spearheading the national mission programs like the National Supercomputing Mission, Microprocessor Development, and C-DAC Mission Mode programs in HPC, AI, cybersecurity, quantum, microprocessor, and next-generation computing. Sir has more than 30 years of diversified experience, ranging from design engineering, project management, and delivery of turnkey projects. Under his visionary leadership, C-DAC has received numerous prestigious national and international awards, solidifying its position as a leader in cutting-edge technology. Since June 2023, Sir assigned with additional charge as Director General, Center for Materials for Electronics Technology. Under his leadership, CMET is continuing to develop leapfrogging electronic materials technologies such as compound semiconductors for high-power devices, ultra-high purity materials for National Semiconductor Mission, quantum and 2D materials, resource efficiency and circular economy through e-waste recycling, niche ceramic and composite materials for 5G, 6G communications. Welcome, sir.
Good morning, all. Sri S. Krishnan, Secretary MeitY. A.S. Amitesh Kumar, Madam Sunita Verma, Professor Bulesh Ahuja, Dr. Suraj from Applied Materials, DG Sameer, dignitaries of the dais, colleagues from Sameer, CMET, and C-DAC industry partners. I welcome.
Is Honorable Secretary MeitY to kindly launch Tec-Verse 2025. Please welcome with a big round of applause. Yeah, we will be. So we are getting.
A gateway to the future of innovation and technology. Today, we spotlight 3 pioneering R&D institutions that are transforming India's technological landscape. C-DAC, Sameer, and CMET. Under the guidance of the Ministry of Electronics and Information Technology, each a powerhouse of excellence in technology. The Center for Development of Advanced Computing, C-DAC, stands at the forefront of India's digital transformation. C-DAC's impact extends far beyond supercomputing, from launching India's first voter ID system to leading breakthroughs in health informatics, language computing, e-governance, quantum computing, IoT, the indigenous Rudra server design, Vega processor, quantum simulators to indigenous accelerators, secure communication systems, blockchain, 112, and many more. C-DAC's innovations touch every citizen. With DIR5 initiatives like the development of Vega processors and RISC-V based SoCs, C-DAC is laying the digital foundation of Atmanirbhar Bharat.
We are using digital technology to transform lives in all sectors of governance, from health and welfare to inclusion and empowerment.
Sameer, Society for Applied Microwave Electronics Engineering and Research is India's vanguard in RF, microwave and electromagnetic technologies. With centers across the nation, it drives breakthroughs in radar technology, satellite and strategic communications, from building indigenous medical equipment like MRI and LINAC to enabling 5G and quantum communication. Sameer is turning innovation into impact. With a national presence and roots in TIFR, Sameer connects academia, industry, and the nation's strategic sectors. Whether it's hypothermia therapy, torpedo testing, or eco-friendly tech, Sameer delivers innovation across every frequency, from HF to light wave. Center for Materials for Electronics Technology, CMET. Innovation begins at the atomic level and scales to national transformation. CMET cutting-edge materials power the future, from 3D printing antennas and batteries to RFID tags and sensors. In Thrissur, graphene and aerogels lead the charge in energy innovation, while silicon carbide and ultra-pure elements fuel the next generation of semiconductors. CMET drives breakthroughs in lithium-ion batteries and supercapacitors, powering a cleaner tomorrow. From wearable cancer diagnostics to IoT sensors, CMET is enabling smart healthcare and strategic electronics. With green technologies that recover rare earths from e-waste, CMET is building a sustainable innovation ecosystem. Together, C-DAC, Sameer and CMET are charting a new course for India's technological destiny. Join us at Tec-Verse 2025, where science meets vision and dreams turn into reality. Welcome to Tec-Verse 2025.
Can we have a big round of applause? Ladies and gentlemen. Thank you. Thank you, sir. In your august presence, we have now launched Tec-Verse 2025. Now, Krishnan, sir, has to attend to a sudden urgent commitment. Therefore, sir, we will request you to kindly deliver the inaugural address. Shri S. Krishnan, sir, has been serving as Secretary MeitY since 11 September 2023, leading initiatives in e-governance, electronics manufacturing, IT, ITES, R&D, emerging technologies, and cybersecurity to drive India's digital transformation. A 35-year veteran of the Indian Administrative Services, he has held key positions in the government of Tamil Nadu, including additional Chief Secretary in the Industries, Finance, Housing, and Urban Development Departments. He was also the founder CEO of the Tamil Nadu Infrastructure Development Board and Chairman of the 5th Tamil Nadu State Finance Commission. Krishnan sir has served as senior advisor at the IMF representing India, Sri Lanka, Bangladesh and Bhutan and contributed to G20 expert groups. He was the district collector of Viruddhanagar district where he resolved a volatile situation and ensured the successful development program through 3-year tenure. Welcome you, sir.
Good morning to all of you, specifically DG C-DAC and CMAT, Shri E. Mahesh, my colleagues in the ministry, Shri Amitesh Sinha, Additional Secretary, Shri Rajesh Singh, Joint Secretary and Financial Advisor, our visiting guests, Dr. Suraj Rangarajan of Applied Materials, Professor Rajiv Ahuja, Director of IIT Ropar, DG of Samir, and Mrs. Sunita Verma, the Group Coordinator in charge of Research and Development in the Ministry. I think today's event is an important event and also a culmination of an initiative that we took some time ago, saying that we need to do a better job of showcasing the kind of technological research that various scientific societies in the ministry have been doing. There's a lot of good work that they've done, a lot of projects that they've taken up. And there is a need to showcase this. There is a need ultimately, since what the Ministry of Electronics is primarily involved in is applied technology and not greenfield research. These are technologies which need to come to the market quickly. These are technologies which people need to absorb quickly. And ultimately, it's public money which is going into this kind of research. And if it is provided even on a non-exclusive basis to a range of partners, it is in the larger public good and larger public interest. So whoever can pick it up and make it available is something that we can contribute to. And likewise, in due course of time, if we find early industrial partners who want to come and use some of the facilities, research facilities that we have, some of the human resources that we have in this area, and that could also be, depending on the kind of contribution made, it could also be something which could be on an exclusive basis. Likewise, I find here that we have representatives of the Indian Institute of Science and various other IITs and other institutions who have been our partners in this research. And one of the good things of partnering with many of these institutions has been that, if not directly, there's been indirectly a lot of convergence of what has happened. Like I said, it's ultimately public money, and it comes through various channels of government. Sometimes it comes through the Ministry of Defense, sometimes it comes through MeitY, sometimes it comes through the Ministry of Science and Technology, Department of Biotechnology, a range of other agencies. But if we are able to converge all these efforts, and if we are able to build on each other's contributions, then that makes the biggest difference. At the same time, I think it's also important to have competition. Sometimes, even within MeitY, you find that different institutes or different institutions, different teams are working on broadly similar subjects. So it is a balance which needs to be struck. At one level, competition is important because that's what keeps the teams on their toes and make sure that they are able to push and contribute. At another level, there has to be convergence and synergy to make sure that these efforts, in a sense, build on each other to take the overall effort forward. So this is an interesting balance which needs to be struck, which you can't have 100% answer every time. Because if you then say that, there is already a team working on it, I won't support something new, there could be an issue there. There are a range of other efforts which have been taken up and which we are working with. And it's important that we try and strike this balance. Just yesterday, I was in a parliamentary standing committee where different ministries were making their presentations on what they are doing in the space of artificial intelligence. So on behalf of the Ministry of Defense, it was represented that, in the Indian Institute of Science, we are working on neuromorphic chip which will ultimately take us in the direction of artificial intelligence. And, Indian Institute of Science has their own fab in which they will actually fabricate this and build it. So I didn't remind the parliamentary committee that, all of this has also been funded partly by MeitY or primarily by MeitY in order to sort of bring it together. But at least it was good to note that a facility which has been created under one ministry of the government of India is being used and is being leveraged to actually support initiatives across different ministries. Similarly, in another meeting, the Secretary of Pharmaceuticals was mentioning that he had gone to IIT Guwahati, where, there is DBT-supported, BIRAC-supported BioNest initiative, and then there is, of course, the MeitY-supported nanoscience fab, and all of this had come together, and there were a number of startups and other innovators who are using these facilities in common, converging whatever has been created in order to produce or in order to move forward in terms of how technology gets applied. And I think that is the kind of synergy that we should be aiming for, which needs to develop naturally. There need to be many ideas which get supported with some degree of convergence and some degree of planning. Some resources there could be some duplication, some things which are done twice over, but by and large, good initiatives build on each other, and it's when there is more awareness about this, more transparency about this, more outreach in terms of what is the kind of work which is going on in each institution, then it enables us to build further. And one of the best ways of doing this is also to reach out to industry, because you also then have your sources of information of the kind of work which is going on in different places and what can happen. And truly, Tec-Verse today is an attempt to showcase some of the efforts that have been made within MeitY's overall aegis of the kind of research efforts that have been undertaken, showcase some of these so that industry is made aware of what efforts have been made, what you can take advantage of, and not just what has already been done, but what is possible in the future. What is it that we can support? What is it that we can take forward? What is it that you can ask us for, and ways in which this can be done? And I can also point out here that the big new initiative here is the ANRF, as you're all aware of, the National Research Fund, Anusandhan. And already, as MeitY, as a constituent member of Anusandhan, I think we've been the lead in that sense compared to many other ministries. We have volunteered and come forward to support programs which we jointly with ANRF. I mean, put in our own research money alongside what ANRF does and try to encourage industry to come forward. One of the early ones that we are pushing in that space is a 2D research center to try and see whether the funding can take place partly from MeitY, partly from ANRF, and the rest coming in from industry. Likewise, in the area of AI as well, depending on which institution wants to come up. Within the India AI mission, what is it that we can bring as funding for availability of GPUs, availability of the compute facility, availability of some of the open source models that can be built and go forward. And like I said, we are in the age of DeepSeek, speaking of AI, and building on each other's efforts to go forward. And I think that is what Tec-Verse should really ultimately end up in, because this may not be pure greenfield research. A lot of it is innovation. A lot of it is building on existing models, building on things which we can take forward, because ultimately the test of the pudding is in what we deliver, and what is it that people of the country are able to benefit from, what is it that they are able to consume. Today we are in an age where it's not technology for technology's sake alone, but also to ensure from an overall security perspective that we have a secure and trusted value chain in key areas of technology, which we can rely on, which cannot be denied to India as a country in certain circumstances. And at the same time, it's an interesting balance between working on it de novo and doing the whole thing ourselves, as against making sure that we collaborate with the right partners to make sure that we are able to leapfrog in some ways and go faster in some ways to make sure that we don't lag in technology, and the technology which is made available to Indians and to India as an economy, as a nation, is inferior to none. And it's a technology which we are able to make sure that we fully sort of engage in the task of nation building and making sure that we deliver the kind of results that the country really expects of us and the country really needs of us. And I think Tec-Verse is an important and significant step, and I would really urge the industry representatives, I would really urge other ministries, other organizations present here, and I would really urge people from C-DAC, the scientists from C-DAC, CMET, and Sameer to take advantage of this event, take advantage of this initiative to make sure that we push forward in this overall task which MeitY has set for itself, and we push forward in terms of delivering what we need to. And the one thing I can assure you is that from MeitY's side, there would be continued support to these efforts from a policy perspective. The minister is very clear as to which direction these efforts need to take, and in terms of funding, in terms of support, in terms of approvals, in terms of making sure that the bureaucratic bottlenecks and all of this are cleared quickly. We are determined to see that it happens. So let me once again conclude by congratulating the team in MeitY, C-DAC, CMET, and Sameer for having put together this grand show here today, and the overall objective which the ministry wants to realize will be realized through this. And we really need to build partnerships. We need to build a range of convergent efforts across industry, across academia, and across the government institutions to realize the overall dream of a technology-driven growth in this country. Thank you very much.
Thank you, sir, for your kind words and motivation. Sir, we now request E. Magesh, sir, to kindly felicitate Krishnan, sir. Can we have a big round of applause, please? Thank you so much. Thank you, sir. Now, we are happy to share that there are more than 1,000 plus participants in the event, and a lot of people are joining us through social platforms. So we wholeheartedly welcome all our guests who have joined us online and to the beautiful audience here as well. Now, I hand over the mic to Raymond Pinto, sir.
Good morning to the audience here, the gathering. Thank you for coming. And also a warm welcome to the dignitaries on stage once again. Friends, the institutes of C-DAC, Sameer, and CMET have over the years contributed to the creation of innovative and indigenous technologies in varied sectors of industry, be it atmospheric sciences, agriculture, forest, coal, dairy, data, cybersecurity, materials for electronics industry, and so on. In this segment now, we shall have the launch of such technologies and products developed by C-DAC, Sameer, and CMET, and also the TOTs and MOUs done with our user agencies in the presence of Shri S. Krishnan, Secretary MeitY, and Shri Rajesh Singh, Joint Secretary NFA MeitY, and also in the august presence of the dignitaries on stage. In order to run through this section quickly, we request the representatives of both parties to come on stage as soon as the title of the technology or product is announced and complete the formalities. We begin with the product launches. We have 4 of them, and the first one is between Sameer and IMD. May I request Director General Sameer, Dr. Rao, and Dr. Mahapatra, Director General, IMD, to be on stage. This product is the millimeter wave-based radiometer for weather forecasting. Can we have the launch video played?
Sameer proudly launches its indigenously developed atmospheric radiometer system, a cutting-edge ultra-sensitive passive receiver for atmospheric profiling. It operates in the K-band, that is 22 to 30 GHz, and V-band, 50 to 60 GHz, to detect radiation from water vapor and oxygen, generating accurate temperature and humidity profiles up to 10 kilometers. The system offers full sky coverage, real-time scanning, and 24/7 atmospheric data with high resolution. Now active at IMD Guwahati, it supports continuous atmospheric monitoring.
Our next product launch is the one between Sameer and the Ministry of Coal, Coal India Limited. They are unable to send an officer here today. So I request one of the team members, Arun Kumar Hedalkar, to come up stage, and Director General Sameer to do the honors. The product is the synthetic aperture radar for stability monitoring of coal mines. May we have the video played, please?
Ground-based radar interferometry is a technology that provides critical information to detect minute displacements in high walls and high slopes, thereby predicting its possible failure. Sameer has demonstrated this cutting-edge technology in open-cast coal mine with in-house development of SAR hardware and algorithms. Presently demonstrated at TRL-7, this technology is most sustainable, safer and smarter solution for slope monitoring and prediction of imminent failures.
Our next product launch is between Sameer and ICFRE. May I request Dr. D.P. Kale, Head of Forest Products Division, and Director Sameer to do the honors. May we have the title of the product is Microwave-Based Bamboo Bending and Straightening System. Have the video played.
Introducing Vraksha, a patent-pending microwave-based system for green bamboo processing. Vraksha uses a 5 kilowatt 2450 MHz microwave source and a unique orthogonal 4-port cavity to bend or straighten bamboo up to 8 centimeters in diameter and 4 feet in length. The system has been extensively tested and validated at IWST Bengaluru. It delivers uniform internal heating with no charring, no discoloration and no structural damage, preserving the bamboo's natural strength and beauty.
Our last product launch in this section is between Sameer and IIGM. May I request Dr. Sripati and Director General Sameer. The product is Ionosonde for ionospheric monitoring. Can I have the video played, please?
Indigenously developed digital Ionosonde, a radar-based system for ionosphere study and space research. It accurately captures ionospheric irregularities to derive electron density profiles, generating outputs including ionograms, sky maps, and drift velocities. The Ionosonde is currently installed at the Indian Institute of Geomagnetism, Prayagraj. It operates unattended 24/7, delivering continuous high-resolution ionospheric data for real-time monitoring to support communication, navigation, and space weather forecasting.
We now move to the transfer of technologies. We have 8 TOTs in line. The first one is between C-DAC and S2M Life Science Private Limited, the technology being CaloSense, a biosensing device to diagnose bacterial diarrhea. I request the representatives of both parties to come quickly on stage as soon as you hear your organization's name being called. The second one is between C-DAC and multiple vendors. This is technology on Flexi Fleet, a fleet management system. TOT on Flexi Fleet. They come on stage. Yeah, between C-DAC and multiple vendors, the technology being Flexi Fleet, the fleet management system. C-DAC Trivandrum or C-DAC with multiple vendors. The next TOT is on acoustic gunshot detection system. Maybe have Sagar Defense Engineering Private Limited on stage. TOT is with C-DAC. Acoustic gunshot detection system. Our next TOT is on nano silver screen printable ink for flexible electronics. Yeah, may I have DG CMET and Glue Track Private Limited, Mumbai, on stage for the TOT of nano silver screen printable ink for flexible electronics. The next TOT is on silver screen printed RFID tags, the technology for NFC. May I request Glue Track Private Limited to continue on stage. This technology is with CMET. The next TOT is again with CMET, with graphene, with the Mad Labs Technologies Thane for the technology of graphene's supercapacitors. Dr. Ratish Sharma. Yeah. Dr. Ratish. Next TOT is again with CMET, Hyderabad, and Ecolith Tech Private Limited, New Delhi, for the technology of lithium-ion battery recycling. Dr. Our next TOT is with CMET Hyderabad and Sonal Magnets Ahmedabad. The technology for rare earth fluoride process tech for magnets. We have now 16 MOUs lined up. The first one between MEPZ says Chennai and C-DAC Bangalore for capacity building programs. request them to be on stage. Next MOU with C-DAC and Make a Village, an MOU on Digital India Risk 5 Grand Challenge. Our next MOU in the form of a startup enablement is C-DAC with Control Sphere for quantum education kits for colleges. Next MOU is with C-DAC and Bell Bangalore for Industry 4.0 at Indian Ordnance Factories. Our next MOU is with C-DAC and TCS for Indian Sovereign Cloud Platform. Next MOU with C-DAC and TCIL towards fostering cooperation in IT and IT-enabled products and for strategic collaboration to leverage mutual strength and drive innovation in emerging technologies. Next MOU is with C-DAC and CSE e-governance services, e-gov services for research, technologies, and operations. The next MOU with C-DAC and Semiconductor Labs, Mohali, for collaborative research in semiconductor domain. MOU for collaborative research in semiconductor domain, C-DAC and Semiconductor Labs, Mohali. Please come on stage. Go to the next one. We have the MOU between C-DAC and Germany for commercial projects in geophysics. Kindly be on stage. Next MOU. Next MOU with C-DAC and Tech-Pool Sigma for reseller collaboration for the DRPN, SARAN, and SDWAN. C-DAC and Tech-Pool Sigma. Next MOU with CMET and IIT Roorkee for R&D in e-waste management. We have our next MOU with CMET Hyderabad and IIT Rupa for environmentally benign e-waste recycle. Next MOU with CMET Hyderabad and JNAR for COE in critical materials. Next MOU with CMET Pune and Voltex Semicon Private Limited for the development of LTCC packages. For the last two MOUs, may I have Director Samir on stage, DG Samir to be on stage, Dr. Rao. An MOU with Samir and Larsen and Toubro Limited, Mumbai, for research collaboration in advanced next-gen technologies, an MOU with Samir and L&T Mumbai. The last but not in the least, MOU is between Samir and IIT Guwahati for the development of accessories for advanced MRI scanner. we have the TOT for C-DAC and SCL Mohali.
Semiconductor labs.
May we have a huge round of applause for all our collaborators, the three organizations, and also for our dignitaries on stage for being so kind to spend their time with the privilege of handing over these TOTs and MOUs and the product launches in the presence of this August gathering. Thank you.
Thank you, sir. We now invite Shri Amitesh Kumar Sinha, sir, IRAS, Additional Secretary MeitY, to kindly present the vision behind Tec-Verse. Amitesh Kumar Sinha, sir, is currently working as Additional Secretary. Thank you, Krishnan, sir, for taking out time from your busy schedule and gracing the event and making it a success. Thank you so much, sir. Shri Amitesh Kumar Sinha, sir, is currently working as Additional Secretary at the Ministry of Electronics and Information Technology, MeitY, and CEO of the India Semiconductor Mission. He is also in charge of R&D in electronics, R&D in CCNBT, and R&D in IT. He is an officer of Indian Railways Accounts Services, IRAS, of 1997 batch. We welcome you, sir.
A very good morning to all of you, dignitaries on the dais, and ladies and gentlemen. Today we have seen that how an R&D effort is seeing the day of the light, and 23 products, MOUs, and technology transfers we have witnessed just now. It's really a commendable thing, and I want to congratulate the team of C-DAC, C-MET, and Sameer. Their R&D team has really worked very hard, and I also want to thank the partner line ministries, government organizations, industry, and academia, who has also collaborated with them in developing this kind of technology and products. MeitY has a pipeline, innovative pipeline of R&D projects. More than 100 R&D projects are in the progress, and whenever they mature, we try to showcase it so that the country in large and the industry, MSME, startups, other government organizations can take help of that. And today is the day where we are showcasing that. The results of these R&D innovations and products development, technology transfer, MOUs will be available on the platform of C-DAC. And anytime anybody wants to access those information, they can go to the website and they can access, along with the contact number and details, so that the handholding and facilitation can be done at any point of time. This is a very good opportunity for startups and MSMEs apart from the government organizations. And I hope that the results will end in developing a technology or a product, commercial product, down the line. We are always promoting this kind of culture, and we want to onboard the customers, the off-takers, since the beginning. And if it has happened, then the purpose and the timeline of R&D also squeezes, and we come to a very fruitful result at an early stage. So we will continue to doing so. Today I have also noted that there are a lot of discussions planned in the plenary session and other sessions on 6G, 5G, medical devices and healthcare. A discussion is also around developing a R&D ecosystem, how it can be made more robust and more effective. In MeitY, we are also funding some kind of research in semiconductors. C-DAC is also playing a very important role in helping design link incentive of India Semiconductor Mission. So I want to again congratulate all the three organizations, C-DAC, Sameer, and C-MET, And this is really very good for all of us to witness this kind of Tec-Verse which is happening today. It is a 2 days event, and I hope that all of you will see in detail whether this technology can be deployed and how this technology can be deployed in the day-to-day activities of our life. Thank you.
Thank you, sir. Your kind words of encouragement means a lot to us, sir. Ladies and gentlemen, we now invite Srimati Sunita Verma, Madam, Group Coordinator, R&D in Electronics, ICT and CCNBT, to share a few words. Madam is the Group Coordinator for R&D in Electronics, IT and CCNBT at Ministry of Information, Electronics and IT, overseeing the entire R&D operations, including National Supercomputing Mission. Her pivotal role extends to crafting policies, evolving R&D proposals, orchestrating their execution, and facilitating their commercialization through collaborative efforts with industrial, academic, and R&D entities. With an extensive tenure spanning over 3 decades, her experience spans over the spectrum of R&D endeavors from research to product development in the areas of artificial intelligence, quantum technologies, microelectronics, nanotechnologies, electronics materials, medical electronics, electronic systems development, perception engineering, blockchain technology, next generation communication technologies like 5G, 6G and beyond, convergent technologies, strategic electronics and communication like cognitive radio, SDR, tactical communications, etc. Welcome you, ma'am.
Thank you and good morning to all of you. First of all, I think it is giving me immense pleasure to see our 3 R&D societies come together to showcase the technologies that they have developed over the years. The purpose of the Tec-Verse is that C-DAC, CMET and Sameer have been doing not only innovative research, but also delivering products for the society, for the nation. But very little is known about the actual work unless there are organizations who are associated to them. So we have tried to showcase in Tec-Verse the technologies, and we have invited all of you here to be part of the demonstrations to see what the technologies can help your organization in how C-DAC, CMET and Sameer can collaborate and develop new innovative products, and also a truly make in India and designed in India products. Along with the demonstrations, about 150 technologies are there, ranging from right from the materials, the long list that you have heard about, before as an introduction, is actually telling the various works of all the 3 organizations that I have a pleasure of working with. And it is ranging from the materials up to the components to the system designs and the on the IT front to the blockchain, perception, cybersecurity, and various other areas, and delivering the products and solutions as required by the customers. So, along with the demonstrations are the panel discussions, as our sir had already mentioned, and I would like all of you to be part of the panel discussions also. Go to our website, click on the technologies, see what the technologies are worth. If you have any suggestions, if you have any customization needs, we would love to hear from you on those fronts. I thank all the attendees here, all the participants, especially from the ministries who are coming, from the industry, from the startups, and the academia who are here to look at and participate in this Tec-Verse and making it a success. I hope in these 2 days that are here, you will be going through the technologies, and we can look at more and more collaboration for these our three R&D societies who are capable of delivering products and right from scratch. And to name a few, we have the National Supercomputing Mission, which is delivering our own supercomputers, which can be accessed. We are given access to the compute power of the supercomputers to the academic institutions, to the startups, and we are looking at the various ministries who need the compute to give access to them also. We are going to expand the compute later on in the next phase. We have various medical devices, equipment which have been developed, some agriculture solutions which have been developed by C-DAC, some new and very innovative material which are used for the strategic and the industrial applications by CMET, the e-waste which is for recycling and for circular economy, which is very important, a mandate given to MeitY. So these technologies and many more, the EMI EMC facility of Samir, the RF ICs and the radar specific communication technologies which are developed by Samir. You can all go through that, and there are a lot of innovations that you can see there as you go along. And thank you once again for all of you for coming here. Thank you.
Thank you, ma'am. I now request Shri Rajesh Singh sir, JSNFA, MeitY, to kindly share a few words with us, sir. Can we have a round of applause? Thank you so much. Sir, please.
My colleague from the ministry, Additional Secretary looking after Research and Development, Amitesh, Dr. Suraj Rangarajanji from Applied Materials, Ahuja sir, Director IIT, DG C-DAC, and DG Samir, Sunita ma'am from the ministry, and my dear fellow scientists, colleagues from ministry, different departments. It's a proud privilege for me, being from finance, to be amongst learned scientists. Most of you are doctorates, which I would be very scared of doing when I was a student. It's a time-consuming activity, and you don't know when you get the results. So, many a time projects fail and projects succeed. So it's a worry for a finance person to see where to put in money. And sometimes it's both. Failure brings their own learning, and successes, we just clap, and then somebody adopts the technology. Like today we had a lot of technology getting adopted. But I think both for research is equally important. We must succeed, we must fail. And we should not have the fear of failure. Of course, for ensuring the success, we should collaborate, and I would rather dare to say collaborate between inverted commas, and expect that all the scientists in this room would, I think, would understand this when I say collaborate. My experience with scientists, both in Department of Higher Education between 2011 and 16 in Government of India, and past 3 years in Ministry of Electronics and IT, I find scientists are very passionate about their work, very clear of their ideas, but just their domain. I would request and urge that look at opportunities. I think you're surely consulting papers and looking at citation indexes, good papers, and trying to enrich yourself and then do your best for the country. Very recently we had good things happening. Some of our fellow Indian, again, after a gap of 41 years, visiting the International Space Center. It's really a proud moment, and a lot of kids would find it very inspiring. So the nation is at the cusp where changes are inspiring, and it has to be then nurtured. these inspiring kids, if they are not nurtured here, I think they'll leave the shores for better opportunities. That's a big problem for our country, and I think a challenge again. Scientists know why this is happening. Are we doing the right things? My question to maybe the group here is, could we engage with younger scientists, retain them here, look at models as to how to encourage them as elders, put them through the guidance and mentorship. So everybody in the room, if you can mentor maybe 10 budding scientists each in this room, possibly we would have maybe 10,000 or 20,000 esteemed scientists. So how do we do it? Do we have a policy for it? Do we have a forum? I think Professor Ahuja, we were just discussing that industry does not trust academics. And we saw this challenge way back in 11 and 16 during that period also. So professors would come for a concept of research park, which as a person in finance and both in the program side, I would look at it as a real estate venture rather than actually a R&D or a startup ecosystem. But we have moved beyond. I've gone and seen that center in IIT Chennai, and I must say with great sense of pride that whoever built it during those days, though I had apprehensions, but that is just the start. That is just the start. We need to reach out. I think academics, again, reaching out, I don't know why we fail to reach out is an issue. Why? Because as scientists, possibly our research is in that closed four walls. We don't want it to be leaked. We don't want to move beyond until unless there is an external pressure to bring all the stakeholders together. And sometimes it is Sunita ma'am, sometimes it is DG C-DAC. I am talking of MeitY. But there's a lot of convergence. Secretary has said in no uncertain terms that is required. And since we are going to enter into the 16th Finance Commission cycle, we would like to support and even give a further funding support to R&D. But then if it should not continue in the same form and the structure that we do. I think projects are scattered too thin across in low funding, and the outcomes are even that lesser. So though I keep on saying those to my colleague, Sunita Verma madam, from time to time, that we can do bigger projects and we can bring industry, let there be industry participation. There's a urge to hold on to patents. I don't know how many of you would agree in this room. And rather than give it back to the society. If you are not using it, let somebody else use it. And if he's doing a commercial venture, then why not get a return out of it? And that is the reason industry is not possibly coming before us and trying to say, from the beginning we are there with the project. Only at TRL 6 and 7, industry has shown interest. So we need to take it backward to a stage where right from the conceptualization stage, so that resources in the country, we are not a 30 trillion economy. So we cannot invest maybe what China is doing, 2.5 or 2.6% of its GDP into research. We are 0.58 or 0.6. This is what my knowledge is. So there's a big gap, what world is doing, and maybe there are countries which would be in terms of maybe close to 4 or 3% or 4% like that. India needs to go there, 3% of GDP. But a trust-based, transparent research ecosystem has to be created without much overlaps. There would be overlaps. And like we move forward from where we have reached. I think it's because of people in this room, people on the dais. There are scientists who are no longer with us, who have given this country missiles and nuclear, I think both civilian use and other strategic uses. Scientists have also given this country I think a lot of pure science research also. But after that, I think few Nobel Prizes we are missing out. Countries missing out on pure sciences. So it's a time that we actually look forward to what we can do right, and maybe catching people young, catching scientists young, encouraging them, and what the government is doing, creating that Anusandhan Research Fund and to bring in collaboration would take us a long way in building a strong nation with a lot of proliferating products which are not only made in India, which are secure from the very design aspect, from the very beginning. We are also funding the downstream industry side by ways of subsidies in PLI and semiconductors. We have already approved 6 such proposals. So industry is coming up. The scientists need to gear up with their designs, with their ideas, so that those foundries are also available in a year's time for them to experiment and possibly take India to a level where I think advanced countries approach us for our technologies. I think it would be a proud moment the day we are able to see that even US or maybe possibly China is also seeking our technologies. I think that would be a very proud moment, and I really wish all the best for the 2-day conference for the team and congratulate them for bringing a lot of MOUs, transfer of technologies, and these endeavors should really continue to see that day where we are leaders in technology and innovation. Once again, thank you very much for giving me this opportunity. Thank you.
Thank you, sir. Ladies and gentlemen, we have amongst us a special guest. करतल ध्वनि से स्वागत करें श्रीमती कैरोलिन देशमुख मैडम, IAS Additional Secretary, Ministry of Social Justice and Empowerment. We welcome you, madam. Please, ma'am. Please, please. We now request our guest of honor, Dr. Suraj Ringarajan, MD, Head of Product Group, Applied Materials, to share a few words with us, sir.
Good morning. Thanks for the invite. Very happy to be here. A lot has been said, and I was very happy to see the exchange of MOUs and a lot of innovation in action. So first things first, I'm very happy to see the dash of color that the people from Samir brought into the conference. A very nice shade of blue. So big round of applause for brightening up the conference. So I just wanted to share 3 things, and this is generally from being at many conferences and addressing the scientists who are here, and the engineers, of course. So the first thing is inflections. So as Rajesh Singh talked about, looking beyond what you do. So one of the things I would like all of you is to read, be abreast of what's happening and all that, and catch inflections, right? Look beyond what you're doing, and that's something that all of us should continue to do. One good case in point is all this thing we are seeing about rare earths, right? This is not the first time. So 2010, the same thing happened, and there is a very nice podcast in New York Times that you can listen to about how different countries reacted to that, and 15 years later, we are again at the same point, again struggling through how we address the rare earth challenge. So looking at global inflections and looking at what you can do to prepare for that is something that all of us as scientists should look at, in addition to what we are doing, where we are looking at a much deeper dive in our own areas of expertise. The second is innovation. I like the theme of the conference, which is linked to progress and innovation. So, and I also liked putting upfront a lot of the MOUs and different product innovations that have come out. It's nice to see them deserve the recognition that they need on stage. So big round of applause for all the innovations that were featured upfront. So how do we get these innovations up, and then how do we hit the window? There is a certain window where these innovations can commercialize and create big impact. So how do we do that? And that's sort of incumbent upon you. The third, just from a conference attendance, right? All of you have been to many, many conferences. Think of what you remember 1 week later. And many of us have all these, we meet people, we listen to a lot of stuff, we go to some showcases and all that. But what can you take away 1 week later? So what I would do is try to think right now, at least 3 new things that you're going to write down, which you will follow up with, right? You're going to meet a lot of people, you're going to listen to a lot of things, you're going to be exposed to a lot of stuff. What 3 new things are you going to learn and try to follow up? And then 3 new contacts beyond your group. I know that in such conferences, people try to sort of catch up and stick to groups. I know this is, I like DG, C-DAC and CMET for arranging this event where 3 different societies are coming together for the first time. So try to reach out to other people that you've not met with. And I think that will be a big impact. Listen and you will learn a lot. So with that, thanks a lot. Thanks for inviting me. And I wish all of you a very successful 2-day event. Thank you.
Thank you, sir. Thank you for your kind wishes. We now request our guest of honor, Professor Rajiv Ahuja ji, Director, IIT Ropar, to kindly share a few words, sir.
So thank you. And first of all, I would like to thank Sunita ji and Amtesh ji and Rajesh ji, and they have said already many things. What I want to say, I will say totally different things actually. Because I'm not living in India for last 32 years. So I see India in a different perspective. As we discussed a little bit with the Rajesh, that Indian academia and industry, they don't come on the same platform. One thing is that industry doesn't trust Indian academia. And in India, there is a situation where academia has to go to industry. But in Western countries, it's not like that. Industry comes to academia. And in Indian industry, they don't have patience. If you want to do research, you need to have a patience. So we cannot make a research within 1 or 2 months. So this is the patience they need. Because research, when we talk, we have to make India as a research-based country. Otherwise, we cannot be a manufacturing hub. We talk about innovation. I always say that research is a mother of innovation. You cannot be innovative. As Rajesh mentioned, that we should bring this culture from the school itself. When the kids are young, or we should encourage our young faculty to come forward, to take this opportunity and grab this opportunity, and we should nurture them. When he mentioned about Nobel Prize, since 1930 or 40, we didn't get any Nobel Prize after that. Why? Because if you look at the Nobel Prize, because coming from Sweden, so we work so close to the committee, Nobel Prize encourage research driven by curiosity. When we are more curious, at that time, we don't nurture you. So we have to come from the schools, and we have to give the opportunity to our young colleagues. Another thing I will also say that academia also has to learn things. we should be care about time actually. That's a problem because academia doesn't care about time and industry needs delivery on time. So this is another issue where we have to work. Another thing is that we have to learn to work in a team. We cannot be individual people. We need to work together. That collaboration is very important. And we sign a lot of MOUs. But when we were in Sweden, we don't sign any MOUs. If we want to work, we work together. We don't want to use MOUs just a paper. We have to have active MOUs. So when you go back after this signing MOU, we have to work on that one. So that will bring the change. And electronics, when we talk about it, we always say that we have to go for a semiconductor area or manufacturing. The country which will control the semiconductor, that will be leading the world. So we have to learn that now. And we have to focus on advanced materials. Suraj is here, so at least their company is trying to do that. We need more companies in the area of the material science or advanced materials. Whatever you want to do, we need materials. We don't have materials. When we talk about rare earths or we talk about lithium or whatever you talk, material is a very important, and materials should be the important branch in all IITs or any institution. But in India, we are not going that kind of importance to the material science. I know that many IITs, the kids want to go only in computer science, the material science is the lowest branch. How we can make India as a manufacturing hub? So we have to work. And when we were talking with Rajesh ji, then we said that what would be the area we should focus? Of course, we are all talking about AI. AI is going to be there for next 30 to 40 years. The agri-tech is a very crucial area where we can use AI in agri-tech and make a difference. And their Ministry of Electronics also play a very important role. I was talking that we are developing this agri-LLM, the large language model for our farmers. We need a lot of compute time, and MeitY can help us to get those compute time on a lower prices so we can be competitive. So we need a food security, so we want to work in AI for agri-tech. And we are very pleased that the ministry has trusted us and given us 330 crore. So we are working with the Ministry of Agriculture also directly. And we have started a program called Digital Agriculture, where again, Ministry of Electronics is going to play a very important role. So we have to work together. This is why I want to say that. And if we want to grow as a society, or if we want to make India as a manufacturing hub, we have to work together. Industry and academia has to come in the same platform, and industry should be very open. Our industry is very conservative. Same thing they will do somebody to do work in Harvard or in Singapore, but they will not give the same project to a professor in IITs or any institutions. Because we have to bring this trust again, and then we have to work together. That's the only way we can grow and we can make a difference. Because we have the huge intellectual manpower and we are sitting on the gold mine. So we can use, we are working on also the digital health. That's another area where we have to focus AI for digital health so we can reach to our remote places in India so everybody can get health and medical, whatever we are getting in the big cities. So with that, I will not take much your time. So you have this technology, this meeting for next coming 2 days. And I hope this meeting will create a new collaborations. Problem is that we meet in the conference and then we disconnect. But we need a continuous talking. We need a collaboration. That's why I want that. I will like to send my PhD students or my young colleagues to send for these kind of conferences because they are going to be there next 30 years. So they should be our face point with the industry. So we have to encourage our young people, especially when you're talking about the research. The research is done by our PhD students. So they should be in the front, not the PIs or professors. It should be they should be. They should get first-hand information. So we have to go in that way, and we should be open and we should trust in our colleagues also. And let's use the facility to other colleagues also. this is also another issue in India. Same department have 3, 4 same machines, but they don't want to share it. So so we can use money more in an efficient way, and if we work together. So India is shining, and I'm sure that we will have a Viksit Bharat by 2047. And Ministry of Electronics is going to play crucial and important role in that one to make India as a Viksit Bharat. So with that, I stop here. Thank you for inviting me. Wish you all the best for next 2 days. Thank you very much.
Thank you, sir. Thank you for sharing valuable inputs and your support. We will now request Srimati Karlin Deshmukh Madam to kindly share a few words with us, ma'am. Ladies and gentlemen, please welcome Madam with a big round of applause.
Thank you. It's a privilege for me to be here. Thank you for the invitation. This is in fact, I am representing my department, my secretary. And sabse pehle, I would like to congratulate MeitY, C-DAC, Samir, CIMET for this event. And of course, their partners with the launch of the new products, the transfer of technology and the MOUs. It's actually really, I would say, it's really awesome to be here to see so much going on. And with the news yesterday of our Indian Air Force Subhanshu Shukla going on the ISS and India making strides in the field of science and technology, it is really a very, very proud moment. I congratulate all of you for these successes, and also like Rajesh Singh ji for the failures. I'm sure that in the effort, in the research and development that must have taken years, that must have taken a lot of pains, a lot of time, a lot of maybe, even disappointments to reach here. We don't look at the failures and we clap at the successes. But I think, like Ahuja ji said, we should also inculcate the habit of the culture of accepting failures and the patience to see an effort go through. So Amitesh ji, Dr. Rangarajan, Magesh ji, Sunita Verma ji, Ahuja ji, Rajesh ji, and Dr. Rao on the dais, and esteemed guests and participants here. From the Department of Social Justice and Empowerment, we look after the welfare of SCs, we look after the welfare of OBCs, senior citizens, transgenders, victims of substance abuse, Safai Karamcharis, beggars. In fact, if we look at the whole, the total population for which our ministry is mandated to take care, it covers almost 80% of the population. And when I look at, I was really happy to see one of the TOTs is with regard to IIT Guwahati with C-DAC on the transfer of technology and accessories for MRI machines. So one of our major target population for the welfare of the senior citizens is for the welfare of senior citizens. We are also looking at technologies for, as we are all aware, we are all going to age. And India as such, I think right now we have 13% of our population in that group of 60 and above. And by 2030, we will, by 2050, we will have almost 23%, almost a quarter of our population will be in that age group. All of us are going to get old. So we should look at technologies which help ease of living when we're all older, when we look at, in fact, nowadays, maybe more than 20 years ago, we have really progressed a lot, and they say that 60 is the new 40. A lot of people in their 60s are still so active, and even though the formal age for retirement is 60, but a lot of people out there with their experience, and if they keep good health, they still can contribute so much to the economy, to the country. And I see, in fact, that is true about scientists, that is true about technologists, that is true about this area of research. There's no age for retirement. So we look forward to people in this sector to keep on trying, and also to have in mind that as part of being a member of the senior citizen group, and also for the senior citizen, can we look at technologies which help ease of living physically, mentally, and even socially also for the people in the senior citizen group. Similarly, we have, as part of our mandate, we have the transgenders. We are aware that, in fact, this area is a very an area where we don't really talk much, we're not very much aware, but these people also have particular issues that a lot of us, we don't understand. Medical problems, social problems, and a lot of other issues also. So can we look at technology? Can we look at some research and development to help tackle the issues, to help face and overcome the challenges that people in the sector also face? Of course, beggary is a problem which is more social and also economical, which we are we're trying to face. And the same thing about victims of social substance abuse also. With the help of the Ministry of Health, we are developing protocols, but can we look at also a scientific and a technology answer or a solution to these problems? So with that, I would leave it up to you, maybe to think about it. And once again, I congratulate MeitY, C-DAC and CMAT and Samir, and of course their partners today, and maybe in the making also for the future. Together we will make a Viksit Bharat. Thank you.
Thank you, ma'am. Thank you for your valuable inputs and suggestions. Dear all, we now have an announcement. We request all exhibitors from C-DAC, Samir, and CMET to proceed to the exhibition hall and kindly keep your stalls ready. You may do so quietly with a smile. And now let us have a big round of applause, because we now are going to start the felicitation ceremony. So we'll give a 5-second pause, request all guests to kindly be seated, and the exhibitors to please move towards the exhibition hall. Now, it is with great pleasure that we present a small token of our gratitude to the dignitaries on the dais. This memento is a symbol of our appreciation for your kind presence and support. May I request Shri E. Magesh sir, Director General C-DAC and CMET, to kindly come forward and present the memento to Shri Amitesh Kumar Sinha sir, IRAS, Additional Secretary MeitY. Can we have a big round of applause? Thank you so much. Thank you. Sir, kindly present the memento to Srimati Sunita Verma Madam, Group Coordinator, R&D in Electronics, IT and CCNBT. Madam, please come forward. Thank you, ma'am. We'll now request Shri Rajesh Singh, sir, JSNFA, Ministry of Electronics and Information Technology. Sir, please. Sir, Shri Rajesh Singh, sir, JSNFA, Ministry of Electronics and Information Technology. Will now request Srimati Karlin Deshmukh, Madam, IAS, Additional Secretary, Ministry of Social Justice and Empowerment. Ma'am, please come forward. Thank you, sir. Thank you so much. Kindly be seated, sir. May I request Dr. P. Hanumantrao, sir, DG Sameer, to please come forward and present the memento to Dr. Suraj Ringarajan, MD, Head of Products Group, Applied Material. Sir, kindly be on stage. Sir, please present the next memento to Professor Rajiv Ahuja, sir, Director, IIT Ropar. Sir, please come forward. Thank you so much, sir. You may please kindly take your seat. May I now request Srimati Sunita Verma, Madam, Group Coordinator, R&D in Electronics, IT and CCNBT, to kindly come forward and present the memento to Shri E. Magesh, sir, Director General, C-DAC and CMET. Sir, please come forward. Can we have a big round of applause, sir? Thank you so much. Thank you, ladies and gentlemen. Thank you so much. Ma'am, kindly be on stage, ma'am. Now, we'll request ma'am to present memento to Dr. P. Hanumantrao, sir, DG Sameer. Can we have a big round of applause, Sameer? Thank you so much, sir. We now invite Dr. P. Hanumantrao, sir, DG Sameer, to kindly deliver the vote of thanks. Dr. Hanumantrao received his PhD from Queen's University, Belfast, UK, MS from BITS Pilani, and P-Tech from CV University, India. Sir, please come. Thank you, sir.
Good morning. We're running short of time. We are late by 15-20 minutes. And we are supposed to start by 11:30 the panel discussion. And it's chaired by ex-DRDO chief, and currently he's holding the post of NSAB, and he's already on the way. So I just want to be brief, but not to miss all the people who have been involved. So it's my pleasure to propose vote of thanks for Tec-Verse. It started a month back, but a lot of effort has gone behind. And probably you might have seen there is a slight change happened in the last minute. Not to lose the phonetics, the Tec-Verse became Tec-Verse, but H was removed. So it probably some might have noticed, some might not have been noticed. We are doing the last minute, the mission control sessions, then such there. And I was the culprit, just found that one of our neighboring country who is sharing the border with us has the same name. Then couple of SOS calls and just requested the entire C-DAC team to change entire total web postings and all the social media postings to be removed and corrected. And absolutely no time, less than few hours, it's completely been erased. All the things you have been printed and all the banners, posters, leaflets, everything been changed less than 24 hours. So effectively the Tec-Verse was rechristened within 24 hours from what it was and what is today. It's an interesting excitement to think about it. So you've been hearing about what we are going to showcase there. Probably 2 days, you get to know the number of discussions, panel discussion, fireside chats, and talking to the leaders and the industry partners, all the people who came here for the technology transfers and the MOE signing, and they have a lot of presence there in the industry, in the manufacturing, production, and research and academics. So my request could be all the young scientists from across all the 3 institutes to collaborate with them and discuss with them and get the insights. And they are the visionary leaders, and you have seen most of the people, some on the dais, some off the dais. They have made a difference in the industry, making what are we envisaged to become Viksit Bharat. So my kind request to all the young scientists to interact with them and get benefited out of that. So program of this mammoth and MeitY in nature could not have happened except for MeitY, Minister of Electronics Information Technology. So, and we're happy to be, at being our parent organization, both C-DAC, all the 3 institutes, C-DAC, Samir and CMET, been part of MeitY for long. And the kind of the support what we get in executing whatever we think or whatever we dream and what we thought we can make it, and they are behind us. And they have been with us and they handhold us. So especially my first personal thanks goes to our secretary, who has been inspirational. At least few months back, in the month of January also, he visited C-DAC Pune. Then everything started. I said, why don't you put together all the 3 institutes and come out and showcase what you're doing, call the industry and see that what the products which are being built, can it be democratized in the country and walking towards Viksit Bharat. So that the day we started, and we had a couple of dates, and they have been slipped there. First we wanted to do in IIT Bombay, where we are stationed. Then we didn't get to some of the timing and the dates of the people there and dignitaries. Then it shifted to Delhi, and even this was the last minute choice, but it turns out to be wonderful. Again, this was not possible except MeitY's and all the staff of MeitY involvement to make this happen at Manexa Center. So my personal thank you to all the people of MeitY and the leaders of MeitY, so make this happen at Manexa Center. Then I also wish to thank Sri Amtesh Kumar Sinha ji, Additional Secretary MeitY, for his guidance. His vision is crucial for enhancement of collaboration among all the 3 institutes, C-DAC, Samir and CMET, and taking the technologies forward for Viksit Bharat. And it's my pleasure to see Mrs. Caroline Ongwa-Reyes, AS Minister of Social Justice and Empowerment, and share her thoughts on a spontaneous note and just giving directions that what we should be looking from different perspective than typically academic and scientific perspective. Thank you for being here, madam. And guest of honor, Sri Rajesh Singh ji, Joint Secretary, is always more curious than more than the finances. Whenever he comes to our office there, he loves to know what we are doing and give the directions. He's very innovative in his approach, and he has been instrumental in bringing a lot of reforms within ministry and within organizations, not only on the finance side and the way we conduct our research. Thank you, sir. Thanks for being here. And we'd like to place on record the support of Mrs. Sunita Verma, GC of multiple verticals. I don't call it as only R&D. So GC of, group coordinator for multiple verticals in MeitY for our meticulous involvement. That's, I need to mention that word, undercoat, underline, meticulous involvement to transform Tec-Verse into great grandeur. And further, we extend warm thanks to entire MeitY team for their support in the event. I'm sure he may not like it, but I wish to thank my wonderful colleague, Sri Magesh ji, DG C-DAC and CMET, and his team for the great cooperation and unwavering support. Let me also thank our friends from CMET and entire team for the constant work for the past few months. I cannot forget my own colleagues from Samir, who have worked relentlessly to make this event as it appears today. As last minute mission checkout, as I said, all this have been transformed into 48 hours mission. So I would like to thank specifically few people who have been involved, not to take all the names, but they made the difference. The entire transformation could happen, erasing all the footprints of what it was, Tec-Verse to Tec-Verse, though it sounds same. It's Rajesh and his team from C-DAC who has done the job. The 2 people which have been from the both sides, Mr. Rajesh Harsh from Samir and Ms. Padmaja and team from C-DAC, they are the people who built this. I just personally want to give a great applause for them. So I do wish to thank the Manexa Center staff for their very polite and generous operation since yesterday to set up the entire, the stalls there and the exhibition and the kindness they show for all the visitors who come there with the politeness they created. It was wonderful to be here. And all the teams which have been identified, the kind of the logistics team, the food team, and it's the most important one there, and the housekeeping team, the audiovisual team, the web streaming, PR, name, there are multiple streams, I mean, numbers stands more than a dozen. All the teams, and led by the eminent leaders out of the teams who made this happen. So I personally congratulate all of them, and I'm sure this experience will make you to soar to the greater heights. So once again, I wish Tec-Verse to be a great success, and I wish all of you stay all the 2 days, get the benefit of what is being discussed here and shared. Thank you.
Thank you, Dr. Rao, for your kind words of appreciation to the organizing team and those behind the scenes. I once again graciously thank all our dignitaries on stage, those mentioned and not, for making time out for this event. We shall now proceed to the technology exhibition stalls outside the auditorium. I request Sri Amitesh Kumar Sinha, IRAS Additional Secretary MeitY, to inaugurate formally the technology exhibits. After this, we shall have a networking tea break, and I request the gathering to proceed with the dignitaries to the area for inauguration and to assemble back in this hall maybe at 11:50 if it is possible, so we can continue with the next part of the formal function, the panel discussion. Thank you. Have a nice day. So please.
is here only. Oh God, you have to take this from here. Ma'am. This one? A lad here? Is it okay? Now what to put to that? This we have to put. Chicken cut. Ma'am, I'm taking out this. ये एक निकाल के ना इसमें डाल दो. Ma'am, what more is required left? Yes. One more one. Oh, one more. We are just pressing. लगेगा ना? वो लगेगा? नहीं नहीं वो वही रहेगा. इसका एक निकाल के और एक नया लगेगा. मैम हमें तो Satish Reddy, you keep it here. This is different. Old one. Satish Reddy. नहीं 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 ये सही है. ये ठीक है. नहीं नहीं ये हटाओ. Then we have to remove the chairs, huh? If it is extra. That's it. Chair this also we can remove, no? No. Sorry, sir is there. Okay, then fine. That's it. So this is over? Over. So how many chairs we need now? Let's see. 1, 2, 3, 4, 5, 6, 7. नहीं 7 है ना? एक हटेगी. ये भाई साहब ये कौन करके देगा? Excuse me, एक चेयर हटा दो. एक चेयर हटा दो. मैम आपकी लगी हुई है चेयर जो आपके हमारी टीम की कौन? बोलो ना. मानिका की टीम की. दोनों आदमी इसके मेन ऑर्गेनाइजर नहीं है. मैं भी ये आप वहाँ रख दीजिए. हम बाद में ये बुलाओ वहाँ चला ही बुलाओ. उनका नंबर नहीं. और इनफैक्ट उनको आप ये बोल दीजिए कि एक टेक आउट दिस थिंग. हाँ दिखाई देंगे वो पानी की बॉटल्स लगाएंगे वो और ये हटाएंगे. ये जो अभी पैनल डिस्कशन के लिए यहाँ से चेयर्स हटाने हैं, पानी के बॉटल्स रखने हैं, ये कौन करेगा? कोई है नहीं यहाँ पे. नेम प्लेट वगैरह तो हमने लगा दिया है बट एक्स्ट्रा है. कौन मैनेजर यहाँ? तो किसने भेजा, वेंडर ने? मुझे नहीं मालूम है, मेरे पास कुछ नहीं, और यहाँ कोई है ही नहीं, ना पानी की बॉटल्स रखे हैं, कुछ भी नहीं है। देखो हाँ, बट ये चेयर एक हटानी है वो तो कुछ।
मैम ये टी अंदर नहीं करना, टी अलाउ नहीं है अंदर, बाहर ही पीना मैम।
कौन मैं?
आपको भी मैम बाहर पीना टी।
है नहीं है यहाँ पे कोई नहीं, जाने दो अभी, वो सब छोड़ के करेंगे। नया बॉटल रखना चाहिए, चेयर को हटाना है। आज चेयर है, साथ ही देखो तो यूज्ड वन। हम साइड कर, अब पानी की बॉटल के लिए तो किसी को बोल देना ना, बोलने के लिए पता है ना किसको बोलते हैं। बंद ही है, बंद ही सकता है नीरज। नहीं नहीं एम्प्टी बॉटल्स। वो नहीं करेगा क्योंकि सुबह तो निरुति ने उसको ही बोला था कि आप बॉटल रखो, तो उन्होंने आके रख दिया। बोल दो जल्दी से फिर ना,
आप इधर ही रहने दीजिए, हटा लेंगे।
ठीक है ठीक है। और धीरज को बोलो ना यहाँ अराउंड से ही रहेगा तो फिर अच्छा है।
जैन साहब ये सब जोरावर में और पानी की बोतल ले आउट करवाना पड़ रहा है अभी इनकी।
ऑडिटोरियम में
चाय हो गई साहब, इन्होंने पी लिया ना पूरा जितना।
ठीक है, हम जाने दो, देखते हैं। हाँ आप कुछ बोल रहे थे,
मैं उसका मोबाइल नंबर ले लें।
आपको क्या
मैम अभी आएगा ना, उससे रखवा देंगे इधर। रखा हुआ था पहले, बट अभी खाली हो गई ना, तो खाली होने के लिए हाउस कीपिंग स्टाफ आएगा, अभी वही है ना, बताना पड़ेगा। मैम आपके जो ऑर्गेनाइजर है वो कोऑर्डिनेट रखना चाहिए। मैं तो अभी इधर पर मोबाइल गिर गया था मैम का एक। हाँ मतलब सर मोबाइल गिर गया था मैम का, वो मोबाइल लेके स्टेज पर ही हूँ मैं।
हॉल में आप दो लोगों को भेज दो, तब लंच की बात।
हाँ स्टेज में जो ग्रीन रूम है ना, सीढ़ी के इधर घुस के देने से बोतल इधर पे और ज़्यादा ले आउट कर देना, ज़्यादा कर देना तो आपको परेशान होना पड़ेगा, स्ट्रेंथ ज़्यादा है। आपका नंबर दे दो मेरे को, सामने वाला नंबर आपका ले लेता हूँ, जब भी लगाना होगा मैं आपको कॉल करूँगा। हाँ, 7 के दे रखो, कॉल आपका नंबर देना, 10। वही वही करना है, 10 के आपको ही रिंग करूँगा मैं हर एक घंटे में ना, बोतल रखते रहना। क्या नाम है? साहब ने बोला है आपको ही रिंग करने के लिए, वो कैटरिंग जैसे साहब नहीं है? हाँ हाँ, ले लिया नंबर, ले लिया, उनको बोला कि फ़ोन कर दिया करो।
ये बोतल उठवा ले आगे साथ में।
We will start our session in 2 minutes. Ladies and gentlemen, please be seated. I'll request dignitaries and members from C-DAC, C-MET and Samir to kindly fill the front seats. I'll request you all, please come forward. Please fill the front seats. Dear ladies and gentlemen, we will start the session soon. May we request you to please move forward. Thank you so much. Thank you for the efforts. We'll request everyone to kindly put the mobile in silent mode. यहाँ उपस्थित सभी लोगों से विनम्रता पूर्वक अनुरोध करती हूँ कि कृपया अपना मोबाइल फ़ोन साइलेंट पे रख दें। और चेहरे पर मुस्कान सजाएं। Thank you so much. Thank you for your patience and cooperation. I'll again request dignitaries, guests to kindly move forward. Let us not keep the front seats vacant. I am Dr. Anindita Banerjee, and I'm joined by Mr. Raymond Pinto, and we are thrilled to be here. We will start the session soon.
A warm welcome once again to visitors and guests and dignitaries invited for the program. We now move to the next part of the program, which I'm sure you will find quite interesting. We are honored to have the presence of eminent and distinguished individuals for the panel discussion titled Creating R&D Ecosystem for Viksit Bharat 2047. The session chair for today's panel discussion is highly acclaimed for his significant contributions to defense R&D and technology leadership. He is none other than Dr. Satish Reddy, a renowned defense and aerospace scientist. Having finished his engineering MS and PhD from JNTU Hyderabad, he worked hard and gained an illustrious career in DRDO, eventually being appointed as Chairman DRDO and SA to Raksha Mantri. Dr. Satish is presently member of the National Security Advisory Board, Government of India, Honorary Advisor, Aerospace and Defense Manufacturing Hub to the Government of Andhra Pradesh. He is the Chief Architect of India's first anti-satellite missile test and has made notable contributions for the development of hypersonic technology vehicles, new generations of long and short-range missiles, drones, anti-drone systems, among many others that have a transformative impact in enhancing the defense capabilities of India. Dear sir, we are sincerely grateful and honored to have with us today. Friends, please join your hands as we welcome on stage Dr. Satish Reddy as chair for the panel discussion.
We now welcome, dear ladies and gentlemen, we will be discussing a very important topic, so let's keep the Josh high. Can we have a big round of applause? Thank you, thank you. We will now welcome Dr. Debashish Datta, superannuated from Ministry of Electronics and IT in 2017. Currently, he is with Reliance Jio as Chief Scientist and Executive Vice President, Strategic Initiatives, looking to edge networks, secure communication, and banking needs. Since 2019, he is a member of Board of Governor of Dehradun Institute of Technology. Apart from AWAB, he continues to be a member chairman of various committees set up by MeitY and DST. We welcome you, sir. Can we have a big round of applause again, please? Thank you so much. We will now welcome our E. Magesh, sir. Sir, please come on the dais. Sir, Director General C-DAC is spearheading the national mission programs like the National Supercomputing Mission, Microprocessor Development, C-DAC Mission Mode programs in HPC, AI, Cybersecurity, Quantum Processor, and Next Generation Computing. We welcome you, sir.
Our next panelist is an internationally recognized personality, having over 3 decades of distinguished service in meteorology, especially weather forecasting and disaster risk management. He has contributed to the modernization of India's cyclone warning system and often hailed as the Cyclone Man of India, and recipient of many prestigious awards and multiple honorary doctorates. He is currently the Director General of Meteorology at the Indian Institute of Meteorology. Please welcome sir on stage. Dr. Mrityunjan Mohapatra, DG, IMD, is also serving as the permanent representative of India at the World Met Organization, WMO, at Geneva. Our next panelist is Sri Harshan Budke, distinguished R&D leader in defense and aerospace technologies. He has made significant contributions to the indigenization, innovation, and export of advanced defense systems over the last 3 decades. He currently focuses on steering innovation for defense and aerospace. Sri Harshan Budke is presently Vice President, Product and Technology Development, L&T, Precision Engineering Systems, Larsen & Toubro. Please, sir, welcome to the panel.
We now invite Shri Gaurav Agarwalji, a highly performance-driven management professional with rich experience of close to 25 years plus in medtech industry, largely focused in cardiovascular space. Sir is a prolific speaker and a part of various advisory panels and mentors several bio-incubators. Thank you, sir.
The moderator to conduct the proceedings for the panel discussions is an individual with impeccable qualifications and expertise. He has a PhD from the Queen's University, Belfast, UK, MS from BITS, Pilani, and BTech from SV University. He has more than 34 years of experience in R&D in RF microwaves and millimeter wave technologies. He has been actively involved in implementation of various future-driven next-generation technologies for both strategic and societal applications, and part of multi-institution collaborative research towards the development of indigenous 5G demonstrated for the first time in the country. He represents India at the ITU global meetings in developing standards for 5G, and presently founding member for the 6G Consortium of India. His work is published in highly referred journals, and his publications are also most referred for long periods of time in IEEE. The moderator for the panel discussions is Dr. P. Hanumanta Rao, Director General, SAMIR, and with his current research areas in 6G solutions, intelligent reflecting services, tile array, phase array systems, RF SoC, etc., is most suited to be the moderator for this program. Please welcome Dr. P.H. Rao to conduct the panel discussions with, and I once again request all of you to give a round of applause to our members on the panel. Sir,
thank you.
Please take over the discussion for creating R&D ecosystem for Viksit Bharat 2047. Thank you.
Thank you. It's more of an informal discussion, but strong in the technical discussions. So you've seen the kind of the panelists we have, very eminent, We have somebody from strategic, somebody from the medical side, and we have industry and manufacturing. So we have like full array of people. So I will take them through the kind of the questions which we feel will add value to the Tec-Verse, what we've been planning. The purpose of the Tec-Verse has been Samir, C-DAC, and CMET has been building the technologies, but in the amount of the democratization, what we expect, the amount of the productionization, what we expect, it doesn't reach there. And we know that from our own limitations and kind of the minimum exposure, what limits us not to get into the business or market in a big way. But the current with the 2047 as a Viksit Bharat, how much we are prepared. So we want to hear from the eminent people. So that's the way the entire panel discussion has been arranged. After the completion of the panel discussion, we'll have the, questions open to the floor, and anyone can ask the question which are relevant, not on typically on the policies and the decisions of the government of India on those things, more to see that how India can be prepared as self-reliant nation by 2047. That are the basic the timelines and the thread on which we love to conduct the entire proceedings. So first, I request Chairman, Dr. Satish Reddy. You heard enough of him about people know him. Most of the people are sitting here. I want to request him to give an opening remarks about what you feel as per the India is concerned, considering the geopolitical situations all around. And India has been forefront of many of such things, both on strategic side, civilian side, as leading the organization which has done large number of deployments. Rather, we can say that there's the Indian defense system, tri-services, cannot be dealing without DRDO. He headed the DRDO for so many years. Then, as you heard, he has been pioneer there in most of the missile technologies, especially with anti-satellite systems. Now, currently, he is advisor on a strategic sector. So, it's none other than Dr. Satish Reddy. I request him to give opening remarks about his perceptions.
Thank you, Hanumantraji. Firstly, I'd like to congratulate the Ministry of MeitY for organizing such an event wherein bringing all the organizations which are working in that area. When I look at the area, actually go through the brochure, almost all the entire research areas are covered in that, what I felt. Looking at the three organizations, whether it is C-DAC, Samir, and then talking about IMD, talking about CMET, right from devices, materials, to components, to electronics, to IoT, talking about communications, 5G, 6G, you have then computing, quantum, so meteorological electronics, and whatnot, and everything you see, they spread across wide areas which covers. So it's a I say very good event where you brought in and then you are putting the exhibition here and people are able to see what new developments are happening and all that. Now coming to what Mr. Hanumantrao has said very specifically, what I feel is India has been evolving from its independence in multiple ways, layer after layer. See, first we were only importers. We were just buying from outside. And many organizations in the country started what to buy and how to test what we bought. This is how. And later, the departments started working on it. Let's say I call it each department, whether it is space or defense or you target atomic energy or MeitY and all that, started in 80s to show that we will build systems. And that time, more or less, industry was very, very few in numbers who were working, and they were also working on based on your drawings and things like that. So most of the organizations were building everything in-house on their own. They are the researchers, they are the developers, they are the designers, mostly they are the manufacturers except getting some components from them. And from that stage, actually industry started seeing some orders coming. And so they started building their capacity. They started becoming more and more manufacturers, more and more manufacturing houses have come in the country. And most of them have been built to print. You will give the drawing, they have been making it. That's how the system. And some more, the system has evolved. Lots of systems in the country. started coming out indigenously within the country. Lots of systems. In each and every department you take, many systems within the India started coming up. That is the stage where industry started migrating itself from build to print to build to specifications. So you say a specification of a system, various organizations or various industries were building those things and started coming out with our own systems. And we have become experts more like in system building. But then what we were lacking till recently was what he said, strategic elements of it. Whether it is the advanced materials, most of the materials what are required for this country and what it is, what we are importing, or we are making the materials competitive here, or the devices, or the components. Like example you see, you take two important examples in that. The battery, we say lithium ion. Till now what we are making in the country lithium ion, almost 90% of them, they are assembling the cells what you buy from outside. Similarly, solar panels. There are so many companies in the country who are making solar panels, but the basic solar cell is imported. Today, yes, there is a change started. A couple of industries or a couple of organizations who have made the cells and trying to make it and all. So the most important thing is working on the core elements what are required are the basic elements, which are the materials, the devices, the components, the sensors, the detectors, and some fundamental elements like microwave sources, if we example talk about it. Likewise, the sources and other things which are required are the ones which we need to build in the country. This is one essence or important element of it. Second, there was also, I think Mr. Hanumantrao asked a question. Having the talent in the country, having everything in the country, but why we are not able to take it forward to the way the advanced nations are doing today. Our own talent who are coming out of our one of the excellent institutes in the globe, they are all going abroad and they are all actually excelling themselves very well. They are all actually going to the top positions also outside. But why we are not able to do the same thing here in the country? This is one important thing, question what we need to debate a lot and what we need to create here. This is one thing. As I said, I feel one thing is, firstly, industry and research organizations or the government organizations, the collaboration has not happened the way real collaboration has to happen. This actually has been like a master-slave philosophy. It has been working. The department makes something, industry takes that, industry produces and supplies to the department, or that sort of a thing. Actually, there was no initiative from industry to come out with research outcomes, or carrying out research, or funding a research and coming out. Why? There is also, see, there is a reason for everything. See, firstly, I always very strongly believe and strongly say one thing about industry. Industry is there to do business. Industry is not there to do research. This is a fundamental point. They do research if there is a business. This is one important thing what you mean. So they all actually look for orders or guaranteed orders. That is where actually what we have been looking at, what are the orders can be given and all that. So as countries started pushing indigenous systems, indigenous capabilities, orders started coming. That is how the industry started flourishing in the country, what we can see. Even in defense itself today, we have about 2,000 industries, tier 1, tier 2 industries. That is because of large number of orders started coming. Now, from here, see what normally industry has been working, what you want, I'll make it. I will do that and give you. That means I take the specifications from you and giving. No, we are not come to the stage where I have this, why don't you take this? Do you want this? Or this is better than what you have today, I have made this. So this comes if we think globally a product about competitive product and making a globally competitive product. See, as I said, the mindset till about a decade back, more or less, has been ancillary mindset. Meaning we have been, most of the MSMEs in the country have been ancillary units trying to make a product what an industry wants. Now from there we have to go to a globally competitive mindset, which I am actually seeing a lot in the startups today. startups' ideas, what they come out, are unique in themselves. So the industry to get into it has to become a globally competitive, rather they have to taste exports in a big way. You are making a product, like we are talking about Lockheed Martin, we are talking about Raytheon, we are talking about many industries like that and all that in the world, because they are able to market in the globe, and the market area is very big. We have to make ourselves that way. Today in India, there are many industries which have come up, who have become part of the supply chain of the globe. Supply chain, they are supplying to Airbus, they are supplying to Boeing, they are supplying to GE, they are supplying to Safran and whatnot, Dassault and all those things. This is a supply chain, whereas where I am making systems and you need to buy from me. And I am a cost competitive and I am having the quality better than you or everything and all that, and my item is a unique item. This has to come. That is, if that mindset comes, and then the industry is already having a good production orders today, then industry will be ready to invest into the R&D, and industry-funded R&D in the government departments and research organizations happens, or even in the academia. So this is what is required, where we all actually, I have been always saying the government should promote the exports from our industries here in a big way. Then what happens is, the government organizations need not be focusing on system development. Government organizations and R&D organizations will focus more on applied research. I've been always saying that the areas are well defined. The academic institutes should focus on the basic research and applied research, maybe 40-60 ratio. The R&D organizations in the country like DRDO or ISRO should focus on applied research to translational research, maybe again 50-50 there. Industry should be focusing on design and development and research in the niche areas, and manufacturing with the innovative manufacturing technologies such a way in that you are cost competitive and not compromising the quality, and the startup should focus on innovation. This ecosystem has to come in the country, working in synergetically, funding each other, not just looking only funds from the government. This is what I expect. So I say in this, Moola Mantra is, somehow we need to make all our industries taste the exports and everything fall along. That's what I feel. Thank you.
I'll add on to the question, sir. I need to add a follow-up question there. As you mentioned about the sources, yes, we had two major institutes in the organization, from DIDO, MTIDC, Sri Pilani. Whenever we go there, they do beautiful piece of work, but still some of the components import, high power sources. Samir also initiated now. I mean, I would love to share with you that we already reached 1.5 megawatt magnetron. By July or August, we'll be able to get the first magnetron, which is functional for our applications. But whenever we go to these labs, they have one query. They say that we get a funding, we reach TRL 7.5 or 6 or whatever stage it is. They need second level of funding for taking it to 10 or TRL 9.5. The government says, we funded the fundamental research, and what are the applied research? You build the solution, go to the industry. Industry said, I don't have energy to spend another 6.5 to 9 because it doesn't yield me. So as I said, return on investment, they do the business. So who is filling this gap of changing from 6.5 to 9? At least 9 you give to industry, they take TRL 9 to 10. So you are not ready directly to give to them, and you need equal amount of funding to converting them TRL 6.5 to 9. So where is the gap coming? That's one question. Second question, industry-driven R&D doesn't exist in India. Industry doesn't come to us asking us, I'll give the money, build this, I'll take. So we've been going back to our ministry, asking them to make the provisions. I just want to share with most of the industry here, we reached a kind of an understanding within the organization and within MeitY, and of course C-DAC also aware of it. If industry is funding 90% or 80% of it, we'll give exclusive license rights for number of years so that they can market it. So because they are investing 80% of the entire development, they get the access license, but we don't give the exclusive rights. We give few years of license, then it becomes a TOT for other industry, not an exclusive. Because somebody funded a full amount of money, why should they fund if they don't get the mileage of it? So this one development which with my secretary we went there and did that. Now I just want to hear your thoughts that why industry still doesn't believe Indian R&D institutions fund what they expect can be built and exported.
And I'll answer the last question first. Why industry doesn't believe in R&D organizations here? I I don't use the same word that they don't believe or anything. Still, our mindset in the country, like example, I just give you Operation Sindoor. Till Operation Sindoor happened, I don't think any one of the people in the country do believe that India possesses such high technology equipment and arms and weapons and all that. Like we only used to hear Israel used to do and all that, and then we never thought. So firstly, we don't have a confidence in our own systems. We believe more and more the imported systems and then imported technology and well-proven technology, and also saying that if I take the technology from outside and it is guaranteed that it can be inducted here, it can be also popularized here is one feeling. This is, second thing is, as we said, also in our country till now, mostly, our mentality has been catching up mentality. Technology catching mentality. See, technology somebody else develops, and then we also develop after 5 years and saying that, yes, we also have developed that. That we also, that mindset, no, we have developed it first time. That has to come. If industry has to take up a product from R&D organizations and confidence, the R&D organization has to come out with a product what world has not seen or world is just coming out. That is one thing. So this is one point. Second, what you said is, if you look at the gap filling, if you say, TRL level 3, 4, somewhere there, and TRL up to 3, 4, the actually R&D organizations, the government funding and all that has to come, and that is where R&D organization does. If you have to take from that research to a technology, there are, I think, new schemes which have come, which have to come much more in the government, like example, technology development funding, or TDB, or IDEX, or whatever the schemes which have come. These are the schemes which actually makes you come out with the technological product which takes up to you to the 6, 6.5. And I am sure that from 6, 6.5 or 7 onwards, beyond that level, industry has to take it up. Industry cannot be a passive industry even now also. They have to come forward and they have to fund and they have to take it forward. Now how to have the confidence in our technologies is what industry has to do. And so if this type of a synergy happens among all these organizations and they have their roles defined and work and you don't have to do others' work, then things happen faster in the country and you will be able to come out with the technologies faster. First and foremost is we have to think ahead and see what the globally a product is going to come after 10 years. I need to work on that. I need to come out with that as first time or in the same timeline along with that. That solves most of the problems. And second thing is, as I said, the market, the mindset of the market that we will be able to market globally.
Thank you, sir. Taking the thread from there, probably I'll ask Harshan Bhutke, Vice President from L&T side. There is so much of indigenization and Atmanirbhar Bharat, the self-reliant, and there is an embargo of imports and all the industries, large industries within the country, L&T, Tatas and Reliance, Adani Aerospace, they have been asked to produce. And we are pretty sure as an R&D organizations, all these technologies, we don't have, at least except leaving few of the organizations, DRDO and Samir and few other organizations within the country, they have at least know-how, I don't call the technology. Expecting the demand, the way India is expecting everything should be made in India. And you should supply numbers to the services. So what kind of obstacles you see reach those targets? You're asked to produce some 3,500, 4,000 airborne vehicles. And there's some kind of technology which is matured, near to be matured. Where the industry stands and what industry thoughts on how to meet the requirements of the tri-services and their Make India initiatives?
First of all, Dr. Hanumant Rao, thanks a lot for inviting L&T to this forum. As Larsen & Toubro is a very big company and we have been in this business for the last 4 decades, I also want to congratulate the government. See, a lot of policies have come which have promoted indigenization. So from Make 1, Make 2, IDDS, obviously there are a lot of gaps and we feel that much can be done. So there are two things which plagues this thing. What as industry, why we are not putting R&D fund is the return on investment for deep tech. It's quite long. So unless the government funds this deep tech, as a big industry today, I can say that, we would love the government to fund us directly. And along with our co-partners, whether it is DRDO, Samir, any government organization, when we go in front and say we will develop, then we will be able to fund the R&D, and we can come back to you and say that, no, we want this to be developed in so much time. So this flow of fund should happen from the user to the company or to the industry who will produce these goods, and that company should say, I require this kind of R&D. If this flow of fund is changed, it will make a big difference. All over the world, the flow of funds is this way, where the government is promoting industry and saying, I want this requirement. That is one. And then the industry will always pump money into the academia. It will also pump into various research organizations, and it will happen. Second thing, the biggest thing that plagues India is this L1 policy. There are policies which are L1, Q1 in other parts of the world, where the government says, I want so-and-so specifications. This may be the benchmark. What is the best possible technology you can bring? Please bring it. Now our RFP has technical specification, length, breadth, everything. So it means the person who writes RFP knows everything. So this is a big flaw. So if we want to promote the future tech, so we need to give customer requirements, saying what does the customer want in the end, and what is the tech, that best tech you can get from that money, and use L1 Q1 method to do this. Unless that is done, we are buying an L1 stuff item, and this will not promote technology. So basic thing is, for us, what prevents thing is direct funding for R&D. We do not have a program where we can go to government and say, I want to develop engines and so on. So this tech without a final output. This is one. Current, whatever is going on, Make 1, Make 2, very few Make 1s have come, which is a source of funding actually. Very few Make 1s have come, and I don't know, government is quite shy to go through this. People are pushing projects in Make 2 where it is industry funded. You take the risk, if it works, otherwise it doesn't work. So this is the second challenge. And the most important challenge, even if we take the risk, the procurement cycle, because GSQR is like a Bible, and the procurement cycle takes 4 years, 5 years. So this is a big cycle where you have to tick every boxes. You have to get 100 out of 100 marks. If you get 99 marks, you are failed. So this procedure, there has to be a change in this policy, so that the first version can come, second version can come, and then there is a incentive for industry to come to this.
Adding on to the same point, see, there was a scenario NCNC, no commitment and no cost, and the industry used to participate and demonstrate and take up. From there, we have moved much forward. We have multiple schemes within the government. We have PLA scheme, DLA scheme, and there are multiple things coming up there. With the change in the landscape from the government policies, still you think that we stand there, or you see a progressive approach going ahead?
So obviously the progress is in the right direction. If you want to catch up with the rest of the world, where you're seeing bigger companies in US, etc., they are leading the thing. So the government is directly pumping money in this companies and in the projects. So that kind of approach is still not there. We still believe that the technology has to be done by DRDO and then you have to give a TOT to the industry. This relation has to change. We want to be the front end. We want to go back to you. We cannot do basic R&D that academia can do. We cannot do the kind of R&D DRDO can do. So we will come back to all this organization and try to extract the maximum value from whatever we get.
Fine, thank you, sir. Then moving on, then we have a mixture of both industry and the government. So we will take on the discussion before going on to the other side. Now we have Dr. Debashish Datta, was ex-MeitY, now he is Vice President in Reliance Jio. You heard from both of them. You have seen from the government side. You've seen the progress what government made when you were in service and what you're today. And Reliance has been doing very aggressive deployments in terms of, especially in the 5G and not on the 6G, 5G sector, they come very aggressively. Yeah. And other systems also, the kind of collaborations they make, even recent announcement from Reliance boss saying that we are going to be completely technology-driven organization. From that perspective,
not from specifically from geo perspective, seeing your stint at this industry and your long association with government. Now you should be able to express your views on that. Why this gap is not filling up, even after so many years of, so many decades of so-called collaboration with industry in India?
At the outset, I will thank you all. Especially Chairman has articulated the theme and the trend, and my colleague from industry, L&T, has said what are the challenges that the corporate sector or the private sector is facing for this funding. You will find there are a lot of multinational companies who are doing their R&D here silently, and all the benefits of that is going to the parent company, whereas whatever the Indian companies are doing are their solo effort, you know. And I will say that there are almost, at present I can say about Geo, I don't know about others, there are about 100 projects that we have executed, and out of those 100 projects, we have seen 10% of them going to production, to roll out. Rest of them have been kept back to see the appropriate moment. So this is one of the things that we look from industry side of view. You can see the production spurring up, production has gone up. And that is due to primarily the policies that has been set up by the government, like PLI schemes and other, and especially in the PLI in telecom and other sectors, where you will see that today we are a reverse trend, you know. We are exporting the mobile phones, which was almost to about 33, we have produced about 33 crore units, and we have exported 5 crore units. So these are the kind of figures that I can quote. And especially from what Dr. Rao said about in the 5G, in the entire 5G core network has been developed by the company itself. So we have not taken any help, except for the E node Bs and G node Bs on which the user plane latches. So next stage, we are going to the AI data centers. For that also, we will be trying to build our AI-based data center stack from the very beginning. So this is a solo effort. So if we are able to get a complementary support from organizations which are working in these areas and which are of our business line, because ultimately we have to garner resource from our sales and other things, because nothing grant will come to us from any external agencies. So I can quote you one example that did create a wonder, I think, when I was there, and it was a graphene production, you know, which CMET was involved at that time, and also, I think, IISc. We promoted one startup, and the startup was not just funding. We said that government will support, we used to call it a multiplier grant scheme. That means even if you put certain amount of money, government will book proportionate or double of it so that you are able to scale up. Today, I think the graphene production, which has started almost 10 years back, maybe has picked up. So similarly, we can definitely, with the support from both sides, and country has all the elements today that we look for indigenous technology, which is comparable to none in the world. So only thing is what we are lacking is the user-driven markets, actually, in which the industry wants to play, because after all, it is their user or their clients from which they take the money and put in the respective sources. So this is, I think, one of the things that I see.
I'll have a follow-up question. Sorry about it. See, when there is as you said, that you build for 100 of them and 10% goes into production, and 90 you are able to keep it there in store, so it can be used there. And why that unique policy applies to the particular industry, why not to X, Y, Z other institutes? What is the difference and the rationale in your approach to the other people? See, when Butke spoke that, why do I invest when there is no market for it? Why do you let the government fund? He still says the government should fund. Government should fund industry, then I don't mind giving to DRDO, I don't mind giving to Samir. That's the way he looks at it. He said, government should fund us. We are the one going to finally manufacture it. But you come up with a different kind of mindset that we build it and we'll find a market for it. Where is the difference? There's a slight difference between both different industries. Forget about who owns the business. I'm not talking about that. On a perspective, where is the perception difference from both are giants? An L&T there, or the Tata Systems, or maybe the Geo Systems. Everybody has been there in their business. Why there is a slight difference of the way you mentioned the approach? What made them, this particular institute, to think differently?
See, basically, if I am able to comprehend the question in the right manner, why a company X, why not a company Y, Z? See, basically, the company X, number two is he should be able to market it out. Second, he should have a domain knowledge to absorb what is being done. Because many of the companies are kind of a service-oriented companies, you know, in which what they see is if I have to provide a service, from wherever I can acquire the resources to provide the service and get the money, let's do it. And that is the time frame that industry looks for most of the time, which is about 3 to 4 years, and where whatever money they put, they're able to make almost twice back into their profits and things.
Beautifully articulated, sir. I'll come back to this. Now I'm going to ask you. See, I'm asking you only, sir. Sir, I'm asking there. So clearly it comes kind of even I have the similar perception. They try to integrate systems because technology is not readily available to you, because you don't have the entire, and there's a range of sub-technologies within a solution. You're building a large solution. You can take a simple example of a kind of surveillance system. We don't have all the solutions, but we have the extraordinary manufacturing capabilities, control systems and motors, and just give an example. Except maybe micro portion. Then first thing you try to latch it, as Dr. Datta mentioned, where to source it. The way our perception, where to source it, and try to get it, so give the solution that I deliver the. You never look for that. Is it available with Samir? Is it available with the C-DAC? I'm not saying that we are only the people. I'm asking that why you don't look at the government organization before looking for signing an MOU with Israel Aerospace, or looking Lockheed Martin, or maybe going to the tails. Why that? That's what the question I've been asking. Why not have faith on these organizations? We don't charge anything like that. It's not that the money is not the point. There is somehow that lack of trust on the R&D, what we do. I personally feel. What do you thought about it?
So as Larsen and Toubro, we have worked with DRDO for a long, and there is a big history, and we have learned with DRDO. So the question, at least for my company, I will say we have a good trust in government R&D. Okay, the pace at which R&D is done sometimes is slower for our requirement, and that is sometimes it keeps us non-competitive in international market. So because you have to give something immediately. So that is one of the things. Second is, today there is no scheme where I can come out and say to DRDO, I have a problem, why don't you work on this? So this is related to DRDO, where unless there is a government funded project, then we go to DRDO and say, TOT. But if I have my own funded project, I am selling to some Southeast country, whichever country in the world, and I say, this is my problem statement, DRDO will say that I have another mandate to do. Okay, so it is not their mandate to work for a private industry. So this is the kind of difference that we see. So that is the main difference. Second, I'll just try to answer your previous question. In in defense industry, all over the world, it is government funded because government is the consumer. Unlike the consumer section, where you can sell it to everyone else. A defense equipment generally gets consumed depending on the political background also, and the government is the main consumer. If the government doesn't support it, no industry will build on them.
Thank you. Sorry, it was a little aggressive from my side, but I just want to share the thought so that people get some kind of idea about it. That slightly, I just add on top of it, yes, the West industry is entire production and the research and everything, they really directly fund. But as you rightly said, in India, the government funds only government R&D organization. It is changing. I just want to say that if you take the programs of the TTDF coming from the telecom department, 30% goes to the industry. Anybody can bid for it. Anybody, you should be Indian citizen. Same thing from TDF funding coming from DRDO. There is no restriction. IDEX challenge coming from DRDO. There is no restriction. So that's not the same what you said. It is changing. Probably may not come as a total system. as a technology, there is a kind of a slight shift in the pendulum. It's coming up. Maybe I expect maybe at least in 5 to 7 years timeline, probably there will be like 100% funding may be happening to the industry. Thank you, sir. Now, slowly moving out of the strategic, enough discuss about strategic. Now we have an expert. He has 2 hats. So he is already MD at imaging with large imaging systems, and he is part of the All India's Medical Devices Association. So I just want to take you through, sir. There is a 2 kind of markets exist in the country, medical devices. One is led by the giants. We have GE, we have Philips and Siemens and Varian. They have their own footprint. And in terms of the C-DAC or Samir or multiple, including CMET, we had a nice, interesting wearable thing which can identify early cancer systems there. There are multiple small systems. Definitely will not replace and substitute what you call Philips and Siemens and GE. And the secondary market, you see the refurbished market. Nothing wrong in that. Somebody is giving a solution where that my services can be affordable for the large population in the country. So that is a large market, the way we see that. Having that kind of 2 levels of a market, and if I visualize it clearly, the secondary market of refurbished market, they don't build anything. They buy 10 of the machines, you need to deliver 3 of them. You break open them and take the parts and put in there, because for them, that's the job. They want to make things running, and they ensure that the service and serviceability of the devices, equipments which have been installed. That's one set of market. Keeping that kind of a scenario within the country, coming from the medical association, the Medical Devices Manufacturing Association, how do you see Indian R&D, could be startups or could be the MSMEs or R&D organizations, how do they gear up to bridge this gap? I'm not saying compete with the GE and Philips. It's kind of a long way. It may happen one day. Everybody, when you say that anything, see, one very fundamental norm in India is, if it's anything made in India, it should be cheap. That concept should go. Personally, I feel, just because it is made in India, it should be cheaper, then only it is be sold in India. I don't believe that. If the quality is there, what is the price Indians buy? Probably we are the largest consumer market. And what we pay for each devices, what we pay, world doesn't pay that much. In terms of our income, under expenditure, if you see, number of people who own the iPhones. As per our income, we should not be owning it, but we own them. That doesn't happen in US and Europe. So considering this kind of a consumer market existing so much, how do you think that Indian R&D and startups and MSMEs can gear up? And how do you envisage, over a period of time, change this landscape for the medical systems and solutions? Over to you, Agarwal.
So first of all, I'd like to congratulate MeitY, Samir, C-DAC and CMET for having such a congregation of leading scientists and some industry experts. And I'd like to thank Hanumant Raoji for inviting me. The question that you ask is a multi-layered question. So I'll attempt to take a few steps back and talk about something that I personally believe. I believe that the world is divided into 2 categories of people. One are the tool makers, and second are the tool users. And I'll substantiate what I'm saying. If you look at the Fab 5 or the large 5 technology giants, which can be called NM3A, NVIDIA, Microsoft, Alphabet, Apple and Amazon. Regardless of anything that you build, you're building a technology, you're building an organization, you're building a product, you will be using products from any of these 5 organizations. So unfortunately, rest of the world is a tool user. They are the tool makers. And this is also evident from their market capitalization. The market cap of these Fab 5 is about $17 trillion, over 4 times our GDP, just 5 companies. Now, putting that in medical device context, our industry is a $14 billion industry, but still about 75% import dependent. A very sorry statistic, considering that COVID showed that there was a chink in our armor. We did not have basics like nitrile gloves, PPE kits, ventilators, oxygen concentrators, remdesivir, so on and so forth. But you see the resilience of the Indian industry. In 6 months, I'm proud to tell you that in our country, in Andhra Pradesh MedTech zone, we today have the largest manufacturing in the world of oxygen concentrators. 40% of ventilators are made in India. At one point in time, I met Dr. Jiten Sharma recently and proud to his visionary leadership. Also, the government of India nudged all the large clothing manufacturers to become PPE kit manufacturers. In fact, we started manufacturing of PPE kits, we pivoted towards COVID supplies, and price dropped from 800 rupees a piece to almost 130 rupees a piece in less than 5 months. We had surplus supply. This is the resilience of Indian industry. Now I'll talk about, you talked about Philips Siemens G, we jokingly call them GPS, GE, Philips and Siemens. Now the combined market cap of GE, Philips and Siemens is about $110 billion. Almost 10 times the size of our domestic industry. Why is that? They make everything from piezoelectric crystal for an ultrasound, to X-ray tube, to a magnetron, to a flat panel detector, to an X-ray generator. Now you could be in any part of the world and making X-ray equipment, you cannot make them without these three. So I think my submission, humble submission, as the joint coordinator of medical electronics would be that we start focusing on being tool makers and not tool users. We need to start focusing on material sciences. We do not have cobalt chromium built in India, titanium built in India, L6 or 316L, stainless steel built in India, molybdenum built in India, rhodium built in India. All of these, PLLA built in India, we need to focus on that. For diagnostic industry, we do not do molecular reagents, chemical reagents, or biological reagents. Like Reddy sir rightly said, we import them and do some value add and sell it as our own. Just to lighten up the atmosphere a little bit, it's like ordering makhni dal from Swiggy, garnishing it at home, and expecting the cost of that good to be same as home cooked food. It can never be. Sorry for using a very crude example, but this is exactly what we are doing. We bring battery packs from somewhere, chips from somewhere else, joystick from somewhere else, LED screens from somewhere else, generator from somewhere else, and try to be globally competitive. Not going to happen.
I like to say here one thing. I fully agree with you. We should not become service providers or operators or use only skill set to maintain. Because you look at most of the machine shops in the country, 90% of those machines are imported and we operate them, CNC machines or anything. And in fact, to my surprise, there are a couple of industries who are making those machines here, but they are not having market. Exactly. They have good machines. I have seen the good machines. Somehow, as I told you, somehow we got used to buying from outside. Same thing happens. You go to any hospital, 90% of the equipment is imported. And we are actually best at utilizing it and then provide the services. And I have been telling the same thing should not happen in the 3D printing, which is upcoming area. We should not become again only operators and all that. We should make 3D machines in the country. There are at least 2-3 companies in Bangalore have come up who are making it. We should actually explore that, and probably government also should support the policies to have the indigenous equipment more and more used. I'm happy, one thing I want to say that in the medical equipment also, of late, in the last 5 years, a lot of things are happening. A lot of industries are coming. They are exporting now in a big way, X-ray machines and all that also. A lot of youngsters are coming out with many medical devices which are of world class. There is a good trend what we can see in the medical field now. And this is applicable everywhere also. See, we should make the machines, not operate the machine. That's the thing.
Thank you, Thank you very much for buttressing that. I would just say that last thing that I'd like to say, Satish ji and Dr. Hanumant, is that I think the buzz today is AI, artificial intelligence. I think in Indian and medtech context, I would like to say AI should be divided into 2 parts. AI 2 is artificial intelligence. AI 1 is academia industry collaboration.
Thank you. Thank you. Maybe just Just moving on from you, because you asked the question about the component should be available there. Now we have Magesh ji, he heads two important verticals within the Indian government, one on the computing, supercomputing, AI, it answers your questions. And CMET is another organization or sister concern. Exclusive research is done on the materials. Now, I would just like to request Magesh ji, say that how we are poised, the kind of the basic devices which we expected to come from there, and the role of CMET in Indians. Very few people know about what CMET does in the country. Many people don't know CMET exists. That's a phenomenal piece of work. I just request all the people to visit our strategic area, the kind of work which CMET has done. You'll be surprised to see that was it done inside India. So that kind of the why. It looks simple, but it's very, very unique in nature and very exclusive. So from that perspective, how do you see our preparedness from CMET side, C-DAC, and you, sir? Who's there from all that, both questions. Thank you.
Okay. From the hardware side, right? So we need systems, we need chipsets for the systems. The chips itself has to be manufactured, it has to be designed. We need fabless. We need people who can do substrates. And after mounting the chip, it has to be tested and evaluated. And all of this, you need materials. 20 plus semiconductor materials, high purity materials are required. Chemicals and gases, other things. CMET was well poised for such challenge, okay? I should partly blame it on the globalization which happened in '91. There was a flooding of cheap materials from outside, okay? Raw materials went out and after value addition, it came with a high import cost to us. That was a very wrong decision, as far as materials is concerned that we gone through, but history, that's an history, we can't correct it. But now situation is different. Today, CMET is well positioned to contribute to the entire ISM Indian semiconductor mission. All the materials, we have POCs, we have done pilot plans, wherein we can have substrates design, which can be used for RF. There are silicon carbide growth which is happening in CMET Center. We moved from 2-inch to 4-inch to 6-inch. Today we have capability to make a 6-inch wafer purely on silicon carbide. And so far we have been talking about making high-powered systems. So anybody could do that. Anybody could pick up a chip from the market and make a system. But making the device itself with the silicon carbide, that is new, that is happening today, thanks to ISM. And then we have a lot of work done on gallium arsenide, gallium nitrates, and more important is this hafnium, okay? So it's a coincidence that we worked with ISRO and developed this hafnium extraction from the atomic energy waste material. It's effluent actually, it's a byproduct of the effluent where rich source of hafnium exists. So this will be a main item in the upcoming silicon. It will be the silicon hafnium oxide which will be the gating material for the upcoming series. So this will be a new trend going forward. So it's basically it's a coincidence that we will be able to contribute to that. So ROHS, reduction of hazardous substance in all the electronics. So we have the only certifying agency in the country. They can tear about any electronic equipment and say what lead content it has. Like that, so we have a capability to do most on the material side. We did work on crystals, piezo crystals, graphene. A lot of work is happening from our Thrissur sector, the graphene materials. There's a Center for Graphene Technology there. Plasmonics, so you can stain a glass and make sure it can be used for different application, sensor application. You can detect snake venom out of that using that material. And you can have a non-conductive, you can pass electricity and have beautiful displays through that. LEDs can be activated through those glass displays. So such works are happening in CMET. So we are well positioned from the materials point of view. But the basic thing that I see is, there are a lot of risk involved. The companies who want to adopt this, they need to be successful.
So out of 100 attempts, only 10 times they become successful. So as Rajesh Singh, JSFA has told in the morning, I mean, we should be okay with 90 failures. And just 10% should be okay with this. This was the problem since the beginning. So that is why we took the least risk activity of going to software domain. That was the easiest thing for us to do. I mean, no risk involved. But we need to create, we have to mitigate this risk for the hardware sector. That needs to happen, I mean, especially the chip design, the materials, the packaging, the testing systems. Anything can go wrong. No, there's no guarantee. You cannot be 100% right the first time all the time. You need to go multiple cycles, multiple iterations to make this correct. So companies need to have that wherewithal to come out of that situation. So they should be sufficiently funded. There should be sufficient tools available. So from C-DAC side, we have something called the DLI scheme, in which the government, under the ISM program, we are offering all these tools, EDA tools. I mean, as part of the grant we are giving to the companies, so they can use them and then do their designs and do the tape out. We help them access the foundries, and we become the intermediary to enable them to access all the foundries, test equipments and all that for post-silicon validation. So today we have about 70 plus organizations already using our EDA tool grid. So it's a EDA on the cloud. So it is being served from our C-DAC Bangalore center. So they are making progress. Few companies have already done the tape out, and maybe that will be a test tape out. They will have another tape out next to that. So this is happening today. And similarly, we have a C2S program where we are enabling all the students to be fully aware of the entire cycle of the chip design up to the materials. That is again happening there. We are about 300 institutes already onboarded. I mean, that is a very small number. So our ambition is to go and now target the entire 14,000 institutes in the country, which is under the AICT. And our biggest target would be one tape out per student. It's called one TOPS. So unless we, as Gaurav told, we need to be involved from the start to end, not piecemeal. Just like we should have the complete understanding of what we really do. So this program, the C2S program, will help the people to go all out from start to end. It's the only limitation is the course duration. They should start early. Maybe it's the third, fourth semester. They should start to come to that stage. So our people are being giving regular trainings for the student, the entire community, and that is also happening. And then we have another program called the drone program. Then that is, there are many things like IoT and other things. The drone is also a very important part, which will cut across materials, systems, and software, and all of that. So we need innovation in the motor itself. Today it is being driven by three-phase motor. Why not increase it to multiple phase? Just like a 16-cylinder jet engine, right? So why not go beyond that? What about the materials, the chassis materials of the aircraft? How better we can do? And what better we can do are the controllers, electronics, and all of that. So there's a vast area where students, other things, people can work. So this drone program is having a challenge. They have already launched a challenge, but today it is restricted to applications. But we would like the challenge to be extended to the entire spectrum of the drone making. These are some of the things happening. So we are well poised to address the needs of the country, and we'll have these kind of things happening. Apart from this, C-DAC on its own, under the supercomputing mission, we have done many machines. We started with importing machine in the past, so we thought that's not the right way to go. So then we started to assemble, and again, that's also not enough. So now we design, manufacture, and assemble the whole system in India, the entire system. The last September, Honorable Prime Minister had really inaugurated 4 machines for the country. So they are called Rudra machines, Rudra series of machines. So it's a lot of engineering work goes into making such machines. Even a liquid cooling system, so that a lot of engineering goes in making that, how to reduce the IT load. Software that will collaborate with all the nodes and then make the system up and running. These are all this kind of work is not done elsewhere. We are the 4th country worldwide doing this kind of works. Today you would have seen in in our display hall, all the new machines, like the one which we are done with Intel, the one which is done with AMD. These are some of the machines which are capable of taking up the AI workloads. They are very compact, petaflops, which is coming in 2 petaflop or 3 petaflop, coming in just one rack. So these are the kind of works we are doing on the hardware side. So going forward, we don't want to leave out on the core designs like GPUs, AI accelerators, next generation HPC processors. So we have a roadmap which is going through all of this. So we will have our own indigenous 196 core, 192 core processor, which is based out of RISC-V. Okay, that is about 3 years away. But in the immediate midterm needs, we'll have an ARM-based thing, which will be again 192 core. We have licensed the ARM core. That is a work in progress. We are working with industry to make all this happen. There are many more things time permits, we can talk.
Great, sir. Nice. I mean, two takeaways, like you're creating a large amount of the skill set in the country, and Intel is closing. Hopefully, C-DAC may take over from there. I expect Intel has been struggling, I've been told. I know how much my information is right. We hope C-DAC will take their place. Let's give a big applause for the kind of work what C-DAC does. Yes. I have one follow-up question there. I think Dr. Reddy's want to lead.
C-DAC also to come out with a large quantum computer very soon, and also be in the forefront with those things. I have a small request. I've got another very important meeting with a very high-level person, so I fixed up around 2 o'clock thinking that. So very happy to be here with amongst you, all of you. I couldn't listen to Dr. Mrithyunjay ji. I request Hanumantrao ji, please excuse me, I want to leave. Don't mind, please. And all of you also.
We'll conclude.
Thank you very much for giving me this opportunity.
We'll continue, sir. We'll continue. Thank you. Rajesh. Come forward. Come forward.
Thank you, sir. We now request Shri Hanumantrao sir to please come forward and present the moment to Reddy sir. Can we have a big round of applause, please? Thank you.
So we'll continue on there. I have a follow-up question, Sir Mahesh sir. There's so much happening, the buzzword there in terms of the quantum computing, quantum communication, AI, everybody talks about it. Quickly, in a minute, how do you feel that India is poised? Every startup says we are doing quantum computing. Everybody comes out to say that I built a quantum computer. Now I saw you have seen one of the startup there, I said they assembled a quantum computer. And there's a lot of proposals keeps coming to the ministry also to build the quantum computers there, then organic quantum computers, and multiple levels of the qubits. How do you see that, how realistic we are in building a quantum computer in the country, from C-DAC perspective as India perspective, with respect to the global scenario? And the way we are following the AI, of course we have a large mission, AI mission there. From that perspective, how we are poised to take on the world in terms of AI? In terms of the native AI, the way our Prime Minister goes around says that like we are going to lead the AI at multiple places. You mentioned that. Taking that threat, how we are ready to take on that? Maybe 1 minute.
See, in my opinion, we should have a quantum operating system running natively on a quantum hardware. That will be the ultimate quantum machine. It is a long way away. So today we don't have that. But we are making baby steps towards that. We started about 5 years back making quantum simulators. We took up a simulator from Atos. We offered training to about 2,000 students at that point in time. Subsequently, we took up QSIM, which was development of Dr. Apurva Patel, IIC Bangalore. We built around that and made a useful quantum simulator. Here also we had about 5,000 plus. Very recently we had a hybrid mode training for about 2,000 people. So we are getting ready for that. We want people to develop applications on those simulators so that once we have the actual machine, these software simulators can actually ride on the actual hardware. So we are getting ready for all of that. We are also now working on superconducting materials from CMET side as well as from C-DAC. Together we are making about 6 qubit, roughly that size. That is indigenous development. That will be out of C-DAC CMET development. So we have already completed certain works with the previous quantum mission, not the current quantum mission, but the previous version. We have worked closely with IISc and RRI. We made control electronics and readout. Basically, they are the communication model, magnetics-based communication model, where you use heterogenic, that kind of principle to convert that to intermediate frequency and subsequently do the readout. So that has been completed. It was a big out-of-form factor board. Now we have optimized that, made it small, which can handle much more qubits than before. So that work is completely done. And there is a work proposal, actual proposal has been approved and work is ongoing to have a reference facility wherein we'll bring in all the other components of the supercomputing quantum machine. So here we have this cryogenics and then the cooling systems and all of that IT and which is necessary to support these qubits. All that has been acquired, some of them from abroad, some we are trying to enable local industries to manufacture and supply. This is also happening. So today, we can't expect a full quantum operating system running natively on a hardware. So we can only think of a hybrid machine. So we have in C-DAC Bangalore a 20 petaflop system coming up. And we are also going to augment that with another heterogeneous supercomputers which will grow up to 50 petaflop. There we will co-locate these hybrid quantum machines so that we can offload certain activities of the HPC workload into the hybrid. So there again we can have AI acceleration, LLM. LLM is not only, we need a domain-specific small LLMs also. So language-specific, there are certain literatures which you can't translate to any other language, right? It has to be natively understood. So we need small language models. So such activities are already happening. So we have a legacy of language technologies in C-DAC. Those teams are working on making SLMs which will run on these quantum machines, on this hybrid quantum machine as of today. But going forward, it needs to be a natively running quantum operating system. That's
Right.
it.
Thank you, sir. Now we have Cyclone Man, so we don't want to bring Cyclone first, so we kept it at the end. So he's the one who built the system for predicting the cyclone in advance there. So brilliant amount of contributions from Mrityunjay Mahapatra, the Director General IMD. So we just want to hear from you, sir. There's you have a very ambitious program in recent when Prime Minister launched the Mission Mausam. How do you see the Indian content can get into those deployments? The amount of the deployments and the number of systems, instrumentation has to happen in the country. Are we really ready there? Again, it becomes somebody buys and puts there. Or IMD is the user. You do a lot of research on the analyzing the data. The way I understand, not on the system side, though there a bit of research comes. Mostly for you, predicting analysis becomes more dominant, so the way we understand. Probably want to hear from you that how IMD functions in the hardware side, on the analysis side, how India is prepared to meet your requirements under Mission Mausam. Thank you, sir.
Thank you very much, Dr. Hanumanji, my dear co-panelists and distinguished delegates. At the outset, I congratulate C-DAC, CMET, and Samir and MeitY for this very important conference and deliberation which is going on at present. So to address the questions, I'll just go a little back. If you remember that we started the meteorological services in the country in 1875. At that time, even we do not have the thermometer. We didn't have the barometer. And we borrowed everything then from Britishers. And even our people are traveling from Kolkata to London to calibrate the barometer. So telling that, if you look at that, India has become self-sufficient with respect to all types of instrumentations, technology, modeling systems, so that we are able to provide the weather forecast not only for the country, but also for the entire region, South Asia, Southeast Asia, Middle East, Asia Pacific. And also we have been a hub for IT, information technology, communications, and all the frontier technologies. So this has been possible because of the many initiatives. There has been government initiatives, but at the same time, there has been public-private partnership. There has been partnership with IMD and many organizations which are present here. And especially Hanumanji, Samir was the first one, I think, in the history who came up with collaboration with India Meteorological Department for developing the ozone Sunday, for developing the radio Sunday. And after that, of course, latest one is handed over today, that is the radio meter, which has been established in Guwahati. Similarly, we have been in collaboration with C-DAC, we have been in collaboration with L&T, we have been in collaboration with many other organizations and industries in the country. As a result, gone are those days when we imported and calibrated all the instruments outside. At present, we are able to find the industry in the country who can provide radar to IMD and other organizations. Also similarly, we are able to find the industry who can provide us the automated weather stations or automated engages and various types of instrumentations like wind profiler or microwave radio meters or something. But while telling all these things, I will tell you that there are still many gap areas in the sense most of the sensors are being imported. It is not being developed in India. So there is a huge scope here to make self-reliance and also to improve our industry. And whatever we have achieved so far, that is because of this partnership, hand-holding. We have helped, we have worked together with all the industries so that it can be digitalized. So one gray area is the semiconductor technology, because of which that we are not able to even have our own sensors developed in the country, even for automated weather stations. Now, coming towards the software, yes, we are known as IT giants, but still I will tell you, the software utilized in the Doppler radar is imported. It is not developed in our country. So therefore, there is a huge scope to improve both the hardware and software, utilizing material science and also the technology, whatever available in the country. Next one, I will just speak that the scope. If you look at this region, South Asia, Southeast Asia, Middle East, all these Asia-Pacific nations, there is no such leadership. We are all dependent upon the Western countries or Japan, and recently China has come off. So there is a huge market, there is a huge scope if you can develop the low-cost sensors, the low-cost instruments, which the countries like our South Asian brothers and sisters can afford to. You will have a huge market if you can provide this type of solutions. The other area where we are lagging is the quality. So we handhold many industries who want to develop the radio and radio instruments. One example I'm talking about, meteorological instruments, where our quality does not stand with the standard fixed by the World Meteorological Organizations. We provide support. We provide our human resources, we provide our space, we provide our laboratory. We'll continue to do that. I urge upon, please, you have to invest and you have to also work upon with concentration. And there is a huge market towards that. There are only 2 or 3 service providers in the entire world. We are dependent upon that. Every time you will find sometimes the single tender. And that solution you can bring out if you can. And there is a huge gain possible in that. Apart from that, if you look at present, the weather forecasting, we say it is an initial value problem in the sense that the science behind weather forecasting is nonlinear in nature, and these nonlinear equations used in weather forecasting, therefore, will be highly dependent upon the initial observations taken off. So therefore, new initial observational tools and technology, quality observational tools are the need of the day. And there is the competition and there is the need for development. So if you look at India, which is the data's first region, we have Himalayas, we have got Arabian Sea, we have got Bay of Bengal, Indian Ocean, we have got the Western Ghats, Eastern Ghats, South deserts, and many other small hill ranges, where the human being cannot afford to take observations. So the remote sensing also, there is a huge scope to work further, where the instrumentation and solutions can help. Geospatial technology, it has come off a long way, but still, if you want to have the solution at present where you can reach out each and every person, the household, then you need the intervention of geospatial technology. You have to develop the data sets on the socioeconomic aspects, the geophysical aspects, the disaster aspects, and also the further solutions which can be easily obtained by the human being. But therefore, it's a huge market, therefore, is possible here, where we cannot help, we will not only help our country, but also we can help other countries. It is a gray area in many parts of the globe, where geospatial technology has not come up so far. So the modeling or forecasting is especially based on, as I told you, the meteorological observations. Then we come up with the mathematical solutions, which we call as the modeling. And these are called the physical models because they utilize the physical data and physical processes, and which is very computer intensive. We utilize high-performance computer system. We have got 28 petaflop machine at present. We also work together with the C-DAC towards that for NSM. And we have also various schemes working together for development of the modeling system. But one area here where IMD is a natural resource for all the industries is the data. The data-driven modeling, the data science. We have got digital data from 1901 onwards, being one of the oldest organizations in the country, and very few are there in the globe. And these data can be utilized to develop many AI solutions or AIML solutions, which will not only help India, but also other countries. So by that way also, there is a huge scope for market for AI, which will be data-driven, and where we are ready to provide the data and the resources to work together with the industry, where we can bring out the solutions. The solution is like this. At present, we provide forecast at the district level or the block level. And as Hanumanji was talking about the Mission Mosam aims at reaching out each and every household with the weather forecast and early warning systems, which they can utilize to minimize not only loss in lives and properties, but also they can enhance their socioeconomic conditions. So to do that, immediately for next 5 years, we have kept the target of the panchayats. So if you go for the panchayats, as I told you, it's the initial value problem, you should have automated weather stations in every panchayat. Ministry of Agriculture, Ministry of Power Sciences, IMD, Ministry of Panchayat Raj, they're working together. But there is a huge market here. So if you can fill up this market, you can develop these systems, then you just imagine how many panchayats we have. And when you go for 2047 Viksit Bharat, I can assure you that every village will have automated weather stations. Just look at the USA now, what is happening there. Every farm has got automated weather stations, which we do not have at present. Apart from that, every industry, whether it is renewable energy, whether it is conventional power sector, whether it is tidal energy, or whether it is health sector, everywhere you will find the enhancement and demand of better weather forecast, early warning, etc., where the need for instrumentation, observational systems, AI-based solutions, and hybrid solutions with physical modeling will be enhanced manifold. So therefore, there is a huge market for this. And in the Mission Mosam, specifically if I tell you, we have now at present 40 Doppler radars, and target is to go up to 126 Doppler radars. Already tendering process is on. I will urge all the industries, you can participate, and also you can compete and find out the solutions for that. Similarly, we are going to establish the radiometers, the microwave radiometers, 25, which number will go on. This is just for only 2 years, this is the target. Wind profiler, similarly, around 25, we are putting up across the country. The objective is that to map in 4 dimensions the atmospheric and oceanic processes, so that we can provide forecast with long lead period and long lead time, so that no disastrous weather go undetected and unpredicted. At present, in the medium range, we predict about 80% of heavy rainfall events. But due to the climate change, etc., these events like thunderstorms, heavy rainfall, are becoming very location specific. It may be raining here, it may not rain, say, for example, in India Gate. So to address towards that, you will need very intense observational network and in solutions based on the data-driven modeling systems. So therefore, when you go towards the implementation of Mission MOSUM, there will be huge scope in terms of the instrumentations, in terms of the AI-based solutions, and also finally we are moving towards the weather management. In the country at present, we have not thought about weather management. We think about the weather forecasting now. The time will come when we reach towards 2047, we will be managing the weather. That means, say for example, somewhere in hailstorm, for example, in Himachal Pradesh, which affects the apples, we go for some firing, the bullets, etc. The people do conventionally. But you will need solutions, how to suppress hailstorms, how to suppress fog, or how to eradicate these pollutions, etc., for ease of living and ease of business and improving our socioeconomic conditions. Similarly, the rainfall. So you may need at that time that you want to stop rain or you want to create rain. So all these are the futuristic, and the solution comes in a long way. We cannot think about the solutions all of a sudden. If you are planning for 2047 for weather management, we have to think now, and we have to act now. So I'll stop here. I'll say that Mission MOSUM promises a very good public-private partnership and scope for improving our indigenous development, Make in India initiative, and provide solutions not only to India, but also the world. Thank you.
Impressive, sir. Very impressive. Very impressive. And I just want to confess my apologies, sir. Rengarajan, sir. I missed to acknowledge you during my vote of thanks. I'm sorry about it. Sorry, but it was in a hurry, very done. Due excuse on that. So we, due to the paucity of time, we don't think we'll take the questions there. And I'll quickly rack up there, less than a minute time there. And the way I look at, we heard from the business leaders, you heard from the government side, you heard from ex-DIO chief, now we have heard from Mahapatra sir, then of course Mahesh sir was there. And of course we've seen what we can build as a C-DAC, Samir and CMET there. Probably the way forward, probably I don't want to take much time, I would love to conclude for more than 10-15 minutes. Probably I'll send a report and give it back. Probably we need to, there seems to be a lot of gap, what we do, what required. That's my perception is. We keep hearing from that. We keep doing and finding who uses it. Then go back to the industry and say that these are the devices I need to make, these are the materials to make, these are the radars I need to make, these are the kind of the forecasting mechanism I need to have, these are the medical devices, which is a gap which I need to build. So we need to do that kind of a kind of auditing of our resources, our capabilities and our technologies versus the requirement from the industry in a medical domain or meteorological domain or strategic domain, and of course telecom sector, and try to map it and identify a few of those segments under which we can build our technologies. When they want, yes, we have a solution. That approach probably may help us to tailor make our solutions to the needs of the industry. Then we not look for that, I made it, who is going to buy? Who is going to market it? Who is going to democratize it? Now we are building, this is what industry wants it. Maybe that could be the approach, probably we'll love to follow it there. I'm sure we are standing between lunch and you. I'll conclude it here. Raymond, over to you. We can discuss during lunch hours, sir, if you don't mind. Okay, fine, go ahead. Go ahead, sir.
Hello. My name is S.A. Kumar. I'm also ex-MeitY, and I worked with Debashish in the ministry. See, India has to become Vikasit Bharat by 2047. And for that, whatever Dr. Gaurav Agarwal has said, we should be a tool maker, not a tool user. And how to go about that? Now, the question is to the industry here, because we have two big industries. One is Reliance and other is L&T. I want to take two use cases. The Fab 5, NVIDIA. NVIDIA today is the $3 trillion company. How it has become $3 trillion company? Because it takes 80% profit of every product it sells. And we have very big business houses in India, like Reliance, Adani, or even L&T. Have they ever thought of getting into that market and at least dent the market for 5%? That is one. Second use case is Tejas fighter jets got delayed because we did not get the engines from GE. That becomes a kind of a use case for the Indian big industrialists to get into jet engine manufacturing, designing of the jet engines. Have they ever thought of it? In case of jet engines, Government of India, Indian Air Force is a assured customer. If not the big industries, who else can do that? That's my question.
Thanks for both the questions. As far as semiconductor is concerned, L&T has recently announced L&T Semiconductor division. So that has now started with what is called the soft part of it, the IP part of it. And going forward, we are looking at the commercial aspects of getting into the fab. That is the way forward. And a company like L&T is keen at looking at these prospects. As far as the engine, you have said, you have rightly said that it is a very critical technology, and we are open to work with the government if government is willing to put money, because it is a huge amount to sustain. And a company like L&T will be keen to work if government takes one step forward and try to invest, and we can co-develop something.
Probably we'll close it now. So sorry for.
Sir, may I request you can take the questions and maybe whatever.
I just want to give a comment.
Your comment, okay.
Greetings to all. Yeah, this is Rakesh Bhatia from Association of Indian Medical Device Industry, colleague of Mr. Gaurav.
Question to him?
No, it's not a question, because it's in continuation to one of your discussions regarding the refurbished or pre-owned medical devices, which somehow couldn't get attention during the discussion. So only one food for thought is, your comments are very good that to allow the access of pre-owned good equipment to the market for the benefit of the people. Now the pain point for Indian manufacturers are that relatively better technologies are available indigenously, but old pre-owned equipment of a previous technology, if it gets access, how logical it is, and can we have a small regulation to like control how much older the machine is to be allowed, because you have to put a limit to something.
Yeah, with this, we conclude this enlightening panel session on creating an R&D ecosystem for Viksit Bharat 2047. On behalf of the organizing committee, sincere thanks to our distinguished panelists for their diverse and valuable insights, for creating a technological R&D ecosystem for the benefit of the nation, for the people, and for society in all areas of technology. A special thanks to Chairperson Dr. G. Satish Reddy, who had to leave, for chairing the session, and to Dr. P. Hanumanta Rao for, I would say, skillfully moderating the discussion. And I'm sure we want more, but we have to stop here. And after a little felicitation, we break for lunch. The sessions will continue as per the program schedule. The audience is requested to go to the banquet hall for lunch. In the meantime, I ask you to put your hands together as we felicitate our panelists on stage. Dr. Hanumanta Rao, could you please hand over the mementos? Yeah. can stand for a group photo, please. And I'm sure we worked up a good appetite for you. Have a good and great lunch. Thank you. See you at the sessions. The exhibition area will be open through the day as well as tomorrow. Please do participate in the sessions that we have, the parallel sessions which start at 2, and then with a tea break at 3:30, and later at again. Thank you.
request you all to kindly put the mobiles on silent mode. It's been a long session since morning. We're slightly behind the schedule, and I will be requesting the moderators to ensure that the session goes ahead as smoothly, and there could be many, many questions. So let us begin the session on next-gen 5G, 6G technologies. And in this session, we'll have two speakers. Both are eminent speakers, and those will be introduced by our moderator for the session. To begin with, I'll invite the moderator for the session, Dr. Arijit Muzumdar, our own person from Samir. Arijit has received his BSc honors from University of Kolkata, then BTech from University of Kolkata, and PhD from Jadavpur University. He joined initially as a research scholar, research associate at IIT Bombay, and then came to Samir Mumbai, where I am as a scientist, and subsequently moved on to Samir Kolkata, where he is officer in charge. He has got a long experience of over 25 years, and he is one of the main player for the 6G Alliance. So, Arijit, the is yours.
Thank you, Avay. And we come to this session post-lunch, which is on next generation 5G and 6G. And as Avay has already mentioned, we have two very eminent speakers. So it is my privilege to introduce the first speaker, Dr. R. David Kolipillai. So he has received his BTech degree from IIT Madras and MS and PhD degree from Caltech, USA. And he has over 3 decades of experience in the field of wireless and cellular technologies. And he is serving presently as the chair of Bharat 6G Alliance. And of course, along with that, he is the Qualcomm Institute Chair Professor in Electrical Engineering Department of IIT Madras. And he is also Dean Planning. He was also Dean Planning Head of the department, handling the portfolios of infrastructure, finance, strategic planning. And during August 2023 to July 2024, he was on a sabbatical at Center of Excellence in Wireless Technology, CVIT, a public-private R&D initiative of Government of India. He has received, prior to joining IITM, he was at Ericsson USA for 12 years, where he had held different technical and managerial positions. In 2000, he became the director of Ericsson's Advanced Technology and Research Department at RTP, North Carolina. He has received many honors and awards, including he is the chair of Bharat 6G Alliance, as mentioned before, Qualcomm Institute Chair Professorship, awarded 32 US patents, 10 Canadian patents, and 19 European patents, and 2 Indian patents, with over 80 journal and conference publications. So I invite Professor R. David Kolipillai to give his talk on cellular evolution to 6G and India-centric perspective.
Good afternoon, ladies and gentlemen. Thank you very much for the kind introduction and the warm welcome. I consider it an honor to be a part of this event where you are coming together as 3 institutions to have this cutting-edge technology symposium. So very happy to be a part where we had an opportunity to hear about the work that is going on at Samir, C-DAC, and CMET, all under the MeitY umbrella. We work very closely with Samir, so in that sense, but it was a good opportunity to hear about what's happening in C-DAC and CMET. So let me start by, first of all, saying why is the whole aspect of 5G and 6G a topic of interest, and what is the excitement that we find around this topic. And then we'll go into the details. So the first aspect is that if you look at the market, a snapshot of the market today, 482,000 5G base stations have been installed and growing, one of the largest markets in the world. We have about 971 million internet subscribers, But the interesting footnote is that 96% of them will access the mobile to access the internet. So India has been labeled, rightfully so, as a mobile-first country. So when you talk about telecom, when you talk about broadband, the first thing that has to be addressed is what is happening in the context of the mobile technologies. It is the TRI statistics says that we are consuming about 21 gigabytes per month, per subscriber per month, and it is growing at a very steady pace. And the operators are indicating that in the next 2 to 3 years, the capacity of the networks, existing networks, will get saturated. As you know, our operators have about 140 megahertz per operator, and they feel that they would not have sufficient spectrum to launch the 5G Advanced. And so we see that there is a market that is growing very fast. It is one of the largest markets in the world today, and it is a market that is really driving 5G technology in India, and its impact is being felt out around the world. So that is the situation that we are in today. But since this is a plenary talk, I thought I'll just give you a glimpse of what is our India's wireless heritage. Goes back to 1895 when the first wireless experiment was demonstrated by Sir J.C. Bose. And then we have the various developments, starting from Maxwell, Marconi, going forward. It's been a very, very interesting journey if you follow along with the development of radio, then television, and then cellular comes in around the 1980 time frame. 1990 was the introduction of GSM, and then the two major developments was the introduction of Wi-Fi in 1999, and then Bluetooth in 2000, and then of course after that the cellular evolution has been the one that has been driving the development. The first smartphone, or the phone which looks like the phone that we have today, was in 2007. And so if you look at this particular journey, it has been an amazing journey once the cellular was introduced into the market. And again, it's a fascinating one to study in detail. Having worked with technology, cellular technology, starting right from the first generation, I thought I would just give you a glimpse. We started out with analog telephony, first generation. Second generation was circuit switched voice, digital voice, and packet switched data, low rate packet switched data. Then packet data speeds increased in 2.5G, increased further in 3 and 3.5G, and then eventually was moving more and more from circuit switch to packet switch. And then in the fifth generation, we are a fully packet switched network, no more circuit switching. And if you look at the timeline, there's roughly a 10-year cycle from the introduction of 2G in 91, the 3G in 2001, 4G 2011, 5G 2020, and then forecast the 6G or IMT 2030 in the year 2030. Again, it's been an interesting development. I thought I would show you what the phones look like. Many of my students today think that the phone always looked like the smartphone that we have today. They hardly recognize the phones from before, but this has been the evolution of the phones that we have. So how do we position? How has the cellular evolution progressed over the years? So when we started to do 2G, we said we can connect anyone at any time, anywhere in the world, and that would be the promise of 2G. Okay? Anyone, anytime, anywhere was the promise. Then comes along 3G, and then eventually to 4G. Then you are always connected to the network. Everyone, everywhere, always connected. You're always connected to the network. That was the tagline of 4G. Then 5G came along and said it's not only people, but also devices will be connected to the network. So everyone, everywhere, everything, basically our machines are always connected. This is the promise of 5G. So where do we go from here? And so we looked at the question and says, what were the three or the major elements of 5G? And it turned out that the three major elements was enhanced mobile broadband, EMBB, ultra reliable low latency communication, URLLC, and massive machine type communication. So 5G would expand in each of these three directions to become EMBB plus, URLLC plus, MMTC plus. But beyond that, where would we go? And it turns out that the expectation was that we would see the introduction of immersive communications, virtual reality or augmented reality, extended reality. That would be one aspect. The aspect of ubiquitous coverage of, say, wireless networks would be another aspect. The presence of IoT devices would be another aspect. And along there came the aspect of AI, artificial intelligence. So interestingly to see that this was a move that was anticipated, and that is exactly how it has happened. Okay. Oh, I think I forgot to switch this thing. Okay. Okay, so basically the aspect of 5G was there. Then the element of the three services, how they expanded and how they have moved forward. Okay, so now when we look at 6G, we look at everything that 5G had, increase the connectivity, and then add two more elements, intelligence and sustainability. So that is how the whole perspective of 6G is developing as we move forward. Now, in terms of timeline, it's always good to see where the standards are and what will be the time frame in which we will see the introduction. So in that context, let me just quickly share with you where we are in terms of the evolution of standards. Release 15 of 3GPP, that was 5G. Release 18 of 3GPP was 5G advanced. And then released 21 is going to be the first introduction of 6G. And what are some of the topics that are going to be covered? Again, we have already referred to them, but good to have another opportunity to see what these topics are. One of the things that you will find is that 5G advanced and 6G more or less are seamlessly going to move together. And some new features are coming into 6G, but a lot of things that are developed in 5G advanced will carry forward. So what are some of those aspects? We can just quickly take a look. One of the things that will start in 5G advanced and then move forward as we go into 6G are the topics of MIMO, enhanced MIMO, massive MIMO, extreme MIMO, all the MIMO related topics. Why are we going to more and more antennas? Because we're going to higher and higher frequencies. The attenuation is more, the antenna sizes are small, so we can afford to put more antennas to get higher gain and therefore the ability to overcome the path loss. So basically, the motivation for MIMO comes from the frequency of operation. One of the fundamental paradigm shifts that will happen in the context of 6G is the emphasis that is being given to integrated sensing and communications. Until now, we always thought of them as two separate technologies, where communications was on communication of data, sensing was understanding your environment. That was a different aspect. Now, what does it mean when both of them come together? And so that's going to be an interesting aspect. How do we achieve higher spectral efficiency? Because you're going to have more users, more applications, and therefore energy efficiency, spectral efficiency are going to be important. And then as you look at the introduction of 6G, then we see that there are going to be more demands in terms of the applications of artificial intelligence and also immersive communications. So this is an interesting point at which we kind of get a broad feeling saying, we know how we have evolved from 1G to 5G, how the requirements for 6G have gradually emerged, and what are some of the things that will carry forward from 5G advanced going into 6G. So let us take a quick snapshot of what were the lessons learned from 5G. And if you were to ask the operators and the equipment manufacturers, these are the points that they will mention. One was that when they introduced 5G, they introduced two flavors. One was non-standalone. That means it depended on the 4G core network. And then there was the standalone. the plan was that you would do NSA first and then migrate to SA. But that transition was not smooth. That was a difficult transition, and therefore it was one of the lessons learned from 5G. There were complexities in terms of the architectural aspects. There were some deployment challenges in the fact that there were many options that were provided by the standards. So when you have a large number of options, then implementing the right subset of options becomes a challenge. There were some new features that, like network slicing, that were being introduced as part of the 5G core network, but these were adopted slowly. And as a net impact was a slow return on investment. So the thought process, even as you start talking about 6G, tends to be saying, okay, make sure that you have a well-dimensioned set of functionalities, both on the handset as well as on the core network. Don't put too many options, don't have too many configurations, and make sure that the architecture is sufficiently simple. And so with that, we say, okay, what are the key expectations or motivations for 6G? Given that we have these lessons from 5G, what are the compelling reasons for 6G? The first and foremost is that there is a potential for new services and new use cases. The first one being integrated sensing and communications. The whole aspect of immersive communication, where you have extended reality and virtual reality. I'm sure many of us are already seeing applications in the marketplace for these type of applications. These are require a heavy amount of data transmission. And of course, the introduction of intelligence into the network. Again, the word AI and ML have been used quite a lot in the media today, but I just want to be very specific, saying that we are looking at the introduction of AI to enhance the performance of not only the radio access network, but also the core network, and also to address the aspects of spectral efficiency and energy efficiency. So it is not just to throw in the term AI, but for a very specific purpose. So spectrum efficiency is going to be extremely important because we have limited spectrum, though we are opening up new bands of spectrum. FR3 is now being considered for 6G, but the spectral efficiency is going to be very important for the simple reason that we want a lot of the services to be in the sub 6 gigahertz, where the propagation is very good. So therefore, this is going to be an important element. Another motivation or reason for the 6G discussions is that even today, even a country like India, where there is a tremendous amount of penetration of terrestrial, we still find that there are coverage gaps. And so the whole promise or the premise of ubiquitous coverage is an interesting challenge that we will still have to address. And in that context, the thought process is that this could possibly be achieved not through more terrestrial deployment, but possibly to integrating terrestrial with non-terrestrial. So that is going to be another aspect. Ubiquitous coverage, very important. Resilient services, which will be the one of the features that will be brought in by the AI technology, will be a very important one. Then, of course, the whole list of what every operator would like to have, revenue growth, energy efficiency, total cost of ownership, network simplification. So these are the aspects that we have learned from 5G. These are the ones that we have introduced into 6G, and this is what we would like to see going forward. Now, where does India fit in this whole picture? And this is what I would like to capture first, and then go into a little bit more of the 6G technology. So look at the six-sided figure that is there on the left, extreme left. 6G is described in the following manner. It says ultra high. You add ultra to everything: bandwidth, performance, intelligence, connectivity, precision, that is positioning precision, and then energy and cost is ultra low. So, but these are the broadly what everyone is thinking that will be the benchmarks or the KPIs of 6G. Now, to achieve this in the radio access network, there are 6 enabling technologies. That's the 6 that you see there. Extreme massive MIMO, you see the non-terrestrial networks, you see the intelligent reflecting surfaces. Again, these are very specific, these are RAN-related topics. But what did India add to this? We said that all of this is good, but at the end of the day, we want 6G to be ubiquitous, we want it to be affordable, we want it to be sustainable. Those are the three elements that we have added, and that is highlighted in the India 6G vision, or the Bharat 6G vision, which was unveiled by the Prime Minister in March 2023. So this is more or less where we are coming from. We want to be at the forefront where 6G is being discussed, but at the same time, keep these three as the metrics or the benchmarks that we are primarily going to be looking at. Now, any presentation on 6G will have the slide that I'm going to show you next, and I want to use that as a starting point for describing the rest of my presentation. Remember, we said that there are three major aspects of 5G. The enhanced mobile broadband, massive machine-type communications, ultra-reliable, low-latency communication. Now, those have been expanded to 6. So basically, you can look at the figure on the left. The inner triangle is 5G. You expand each of these to be enhanced, and then you're going to introduce 3 additional parameters: integrated sensing and communications, ubiquitous connectivity, and the aspect of bringing in AI into the network in the radio access part and also in the core network. Now, how does this translate to what 5G will already provide for us? That's the circle that you see on the right-hand side. Everything that is in green is already supported by 5G and 5G Advanced. We will enhance these features to improve. For example, we will enhance reliability, latency, we will be able to enhance the connection density, spectral efficiency. These are all there in the system today, we will enhance them. Then comes the blue, where we will introduce the new dimensions, and that reflects what you see on the left-hand side. You see the aspects of the AI features coming in, the integrated sensing and coming in, the sustainability coming in, enhanced positioning. So this is broadly how we understand the positioning or the requirements that will be set by ITU for any system that will be classified as the 6G system. Now, it's always interesting to see where all are these blue portions, where all are they going to affect. And it turns out that they're going to affect every part of the network. It is going to affect the radio technology part. There are several new things enhancements that we would have to do to meet these new features. It will affect the core network. It will affect the radio access network. So basically, it will affect all parts of it. It will also affect the spectrum band of operation, and depending upon the band, the rest of the network will also have to adapt itself. So 6G is going to bring in a lot of new additional technology challenges, and therefore this is going to be a very, very interesting period for us. Now, let me take a few of these technology pieces and then share with you and then bring this presentation to a close. The first one that I would like to share with you is, what are the challenges when you say that I want to do integrated sensing and communications? Integrated Sensing and Communications, short form ISAC. Now, we want to have the situation where the same infrastructure, antennas, both at the base station and the mobile, are doing both communications and sensing. So the first question that comes about is, are we using different resources for sensing and different resources for communication? Are we going to partition, or are we going to have it integrated? Is the waveform for communications going to be different from the waveform for sensing? How do we get the maximum benefit out of integrated sensing and communications? Is there a role? When you say, I just want to communicate, base station wants to communicate with the mobile, we know it's already done from 2G, 3G, 4G, 5G. But if you say that I want to also study or sense the radio environment around the mobile, then you ask the question, this is not a linear problem. It's a non-linear problem. And maybe this is where some AI ML techniques may come into play. We don't know. So that is the aspect. So sensing is a radar function, communications is what we know. So how do we do that in parallel? And even as we start to grapple with these fundamental topics, we're already seeing that there are some enhancements that can happen to sensing. For example, if you have a blocked line of sight path, then maybe the use of an intelligent reflecting surface is going to be an important element. Samir is at the forefront of developing these IRS building blocks. So again, that's an important aspect. Now, if you can't do it with a terrestrial part, can you bring in a non-terrestrial part, maybe a UAV that can help you in the sensing? So again, very, very interesting problems, interesting challenges. But more importantly, let me go back to the aspect of what waveform should we use in this. The simplest way that I can explain this problem to you is that the channel that we see in wireless communications has got variations in time, and because it's a dispersive channel, it has variations in frequency. So basically, it's called a doubly dispersive channel. Variations in time, variations in frequency. The bottom right-hand side is the channel that we encounter. If I go across time, channel will change. If I look across frequency, time will change. Now, this same channel, which is very difficult for me to, first of all, to sense and then to do measurements on, if I do two Fourier transforms, one in the time dimension, another one in the frequency dimension, we move to a domain called the delay Doppler domain. Now, the radar people know that that is, I'm sorry. Thank you for indicating that. The delay Doppler domain, this is what the radar people know. This is how you would do a sensing of the channel. And so the whole aspect of what is the best waveform for us to do the sensing. And so, for example, if you were to look at what you could do in the time frequency domain, so look along the x-axis. If you had pulses that were limited in time, basically they would be very broad in frequency, so you would not be able to differentiate between two different Dopplers. So that will produce for you some fading or fluctuations in the frequency axis. Similarly, if you did it with short frequency pulses, then you would not have resolution in time. But in the delayed Doppler domain, you can have resolution that gives you a much better representation of the signal. Now, how do you bring in this delayed Doppler representation, this waveform, into the system? That is the challenge, and that will be something that we will have to discuss. Another important element that will come in as part of the evolution of the cellular systems is the simplification of the architecture and the move from custom hardware to GPUs. And this is going to happen. One of the ways in which we see that happening is that you have the segregation of the functionalities: the radio function, the distributed function, the centralized function, and then the RAN intelligent controller. Now, we could do all of these in the traditional way, but given that there is the potential to introduce the aspects of AI, we find that AI can come in not only in the RAN intelligent controller, but also in the other elements as well. So basically, the whole aspect of decentralization, virtualization, and the possibility of introducing AI are important elements. Now, where all can AI have an impact? Again, I would limit myself to the radio access network. It can affect the layer 1, the physical transmission layer. It can affect the layer 2 and above, where you look at the medium access control, the mobility, all of that. And then it can also it can impact the higher layers. It can affect the whole aspect of how do we measure channels, how do we report the channel feedback. So that's basically what we call as channel state information compression. AI can affect the way we keep track of the user's mobility, which means that we can also use that information in managing the narrow beams that we are going to be radiating towards the user. So basically, many aspects on the physical layer, the whole aspect of how do we optimize the network resources so that you save on energy, save on the spectral efficiencies. Those are also key elements that we want to understand. This is, the next slide is something that I believe you are very familiar with, but I just want to mention that there are, when you talk about bringing in AI into the telecom network, you have two entities that are not equal. We have the base station that is a trusted entity. We have the UE that is not the trusted entity. So basically, how do you share, or how does AI come in? So if you talk about a model that is developed at both ends independently, but information has to be shared across them. So that is one type, because the network says, I don't trust you, but I will give you some information so that at the end of the day, both of us have that. The second one is where the network trains the model and then gives you all the details to the user. The third one is the network is the conductor, and the UEs are doing their own optimization, but the base station controls that. So basically, which of these models, for which application, for which use, again, interesting that we need to find out. One of the interesting or very exciting applications of AI happens to be at the intersection of IoT or cyber physical systems and AI. And this is the aspect of digital twins, where you have a physical world system, and using a lot of sensors, real-time sensors, you're able to create a digital replica of that. And then you are able to then look at perturbations or modifications of the digital world, which you can then implement in the physical world so that you can get a optimized performance. So basically, the whole aspect of being able to optimize not on the live network, but on a model of the live network, and then make a modification. So basically, this is going to be a very, very interesting aspect that we believe will come in the future. Okay, so we've talked enough about AI. What about ubiquitous coverage? And in that context, Release 18 said that we must look at the integration of terrestrial network with non-terrestrial networks. What are the non-terrestrial networks? Today, we can have a GEO, which is at 35,000 kilometers, or a MEO, medium Earth orbit, at 8,000, a LEO starting anywhere from 400 kilometers, or you can have a drone which is, at a few hundreds of meters, maybe. Anything in between, yes. There is the new or emerging technology called high-altitude platform stations, which is likely to operate in the stratosphere in the 20-kilometer range. Again, it has a very interesting scenario, because you can look at it in the following manner. The HAPS basically is more or less stationary. It is at a height of 20 kilometers. So you can imagine that it has a much better link budget compared to even the low Earth orbit satellites. It has less problems with Doppler because you're not moving as fast as a low Earth orbit. It is a stable environment at 20 kilometers. They say that there is adequate sunshine, there's not much of atmospheric turbulence. So basically you can operate for several months on solar energy. So again, this is the aspect of ubiquitous coverage. Maybe we are looking at it to see how this is going to play a role. Again, one HAPS can cover a radius of 100 kilometers on the ground. Another topic which I'm sure the audience here will appreciate is the aspect of radiative near field. Now, when we have these very large MIMOs, we are usually used to thinking that the way to address or leverage this is to create narrow beams and do what is called space division multiplexing, spatial multiplexing. Now, what we are finding is that when you have these very large arrays, then the near field tends to go further than before. And what we are finding is that you can now start to multiplex not only in the spatial dimension, but also in the depth dimension. Again, how much of it can we leverage? And these are some interesting opportunities, and I'm sure the scientists in this audience will definitely be able to make some very significant contribution in terms of the beam width, beam depth, and how do we leverage it for multiple access. Now, let me say a few words about the IoT aspect, the device communications aspect. Some of the key elements that we must address are the issue of connectivity. Do you need 6G or can you do it with earlier version? Yes, basically connectivity is an important issue. What protocols you will use, what is the security of the data that you will use, and is there any intelligence that will come in terms of the compression of the data or the fusion of the data. Again, these are important aspects that we must look at. It is believed that there will be 4 major types of machine-type communications. The first one will be broadband IoT, where you are looking at the need for a broadband technology to carry the large amounts of data. The second one will be massive IoT, where you will have a large number of sensors, but very low data rate. That will also need to be supported. Then you have the aspect of critical IoT, time critical, extremely requirement of high reliability that is needed. And then finally, you're looking at ambient IoT, where you're looking at devices that are drawing energy from the ambience and therefore don't need a source of power. Again, this is for certain applications. Very, very interesting that this will happen. So when we talk about IoT, we are basically talking about Industry 5.0, where potentially we have the situation where man and machine will work together in close quarters with a very human-centric approach to that. But then you say, okay, what are real life applications? What I would point you to would be smart transportation, where you have different types of devices talking to each other. Vehicle to infrastructure, vehicle to vehicle, vehicle to person. And so these are the different, so vehicle to vehicle can be for platooning, it can be for safety. Vehicle to infrastructure could be for safety, for maintenance, for information. Vehicle to person, again, so this is the whole domain of how IoT can be brought in. You can have a cyber physical system, you can have a smart transportation system which is significantly enhanced in terms of performance because you now have the technology that is able to support that. Now, to conclude this presentation, let me give you what is the India-centric perspective and where do we see ourselves fitting in and where do we contribute, where is the access. So basically, the Bharat 6G vision says that we have these 3 aspects: affordability, ubiquitous coverage, and sustainability. And also the ambition of India being a large market, that we should be one of the countries that are at the forefront in terms of global contribution. We look at it in terms of active contribution, in terms of standards in 3GPP, and into ITU, and through our own standards development organization, TSDSI. So the Bharat 6G vision says that we will look at the 6G strategy in 2 phases. Phase 1, which is up to 2025, where we are looking primarily at early work, R&D work, some initial proof of concepts, so preparations, if you would call it. Then phase 2 is the serious part where you go from 2026 to 2030, where you are actually developing ideas, you're looking at test beds, looking at creation of intellectual property, and then the support of standardization. So this is what we are looking at. So to enable us to achieve this, the Bharat 6G Alliance has been formed. And the Bharat 6G Alliance has got all the stakeholders, operators, academia, government labs, R&D organizations, manufacturers, technology companies. Basically, everyone is part of that. It has been divided into 7 working groups. There's a spectrum, devices, applications, the sustainability, use cases, and outreach. So basically these are, and we also have the establishment of international partnerships. So basically this will be our vehicle to carry forward India's ambitions in the 6G area, and of course also the feeding of inputs into the standardization aspects. So if you were to look at it, this is how it is structured, the Bharat 6G Alliance, the 7 working groups, and also the role of experts, and also the ability to interact with different organizations and R&D labs to initiate the work that is happening within the Bharat 6G. Now, in this context, we must acknowledge that there have been a tremendous amount of work that has been done by the government in terms of the various initiatives that have been done. So what I would like to do is quickly highlight for you what are some of the aspects that we can highlight, saying that the initiatives that by the government of India through the Telecom Technology Development Fund, through major projects like the India Stack, the Bharat 5G RAN project, and also the elements which we have introduced into the system. There are other projects as well. I'm not able to move forward. Okay. Could you help me skip one slide? Yeah, I don't know, for some reason the slide is getting stuck. Okay, yeah, maybe just hold. Okay. We also want to leverage the various national missions like the quantum mission, the semiconductor mission. All of these will have an impact on what happens in terms of the telecom technology. We also have the funding agencies, the DOT, the DST, MeitY, and the ANRF. So basically, we have a tremendous engine that is working to develop technology for us. So with that, we can then go on to looking at what are some very specific 6G related initiatives. We have the centers of excellence in 6G. We also have the aspects of the projects that have been initiated in 6G. For example, the 2 major test beds funded by DOT, one on advanced optical communications and terahertz communications, which is being led by Samir. And also the policies to support that, the Telecom Act of 2023, the Telecom Regulatory Sandbox, which basically gives us permission to do trials with very ease of license, obtaining a license. So again, these are elements that we definitely want to leverage. As a specific illustration, let me mention the 5G and Beyond project, which was funded by MeitY. It was a 3-year project, 8 institutions, 100 crores, and the project is now completed. I will just report on what IIT Madras was able to do in that. In this 3-year period, we were able to file 41 patents, 76 contributions to the standards, many publications, and training of a large number of individuals. Now you multiply it by 8, multiplied by number of different projects that are running, a number of institutions that are funding this effort. We believe that we are in a very good situation as far as the aspects are concerned. Bharat 6G Alliance has been very active in terms of establishing collaborations around the world. You can see that literally all the continents are covered. And we also have very strong participation from different organizations within India. Samir is a member, one of the governing council members of Bharat 6G Alliance. So what this says is 6G is moving. And we have strong support from within the country, we have strong support from the government, and we also have an interest from the global community because of the nature of the market in India. So, to summarize, what are we gathered here for? To build a strong 6G ecosystem. I believe we can work together, and definitely the people in this room can make a significant contribution. So, we have a ecosystem that is starting to come together. We're starting to see some very exciting developments in terms of technology, integrated sensing and communications, non-terrestrial networks, the introduction of AI and ML, new services like immersive communications. India is a large and a strong market for 6G. We have a vehicle for us to move forward, which is the Bharat 6G Alliance, guided by the Bharat 6G vision. Multiple R&D initiatives, and a very strong role for Samir, C-DAC, and CMET, and overall a very exciting time for telecom in India. So with that, let me wish all the participants the very best, and happy to answer questions or also respond by email later on, davidk@iitm.ac.in. Thank you very much.
So we thank Professor Koel Pillai on behalf of the organizers
for delivering a very, very engaging talk. We are open for a few questions from the audience. So if you have any questions, please.
Professor, a very good afternoon to you.
Good afternoon.
My name is Sumit Chauhan. I represent a company called Desto Solutions. We are into automobile security, our Indian startup. So when we saw your presentation on 68 kinds of vehicles, up to the very fact that as we move away from ICE-based automobile platform to completely connected vehicles, whether those are passenger vehicles or commercial or defense vehicles, 6G will play a very prominent role in the way they could be communicating. But one of the very most aspect of the communication that we are not looking at is the cyber resilience in this whole aspect. So even 5G has inherently challenges in terms of protocol, in terms of the stack on cybersecurity. Will 6G be able to do something on it, or this leaves us room for a company like us to build a platform to cover the cybersecurity stack on the 6G network? Okay. Thank you.
Thank you very much for the question. Again, very, very important question that we need to address, regardless of which generation of cellular system we're talking about and which application. But as rightly pointed out, in the context of transportation, definitely the whole aspect of security and resilience is going to be important. And if you recall the slides, one of the aspects that I had highlighted is that in 6G, that is one of the aspects that has to be addressed, the whole aspect of resilience and security. And to answer your question, is this a solved problem today? Far from it. So is there an opportunity? I believe it is there. And so we must work together to understand what are the security challenges and how best we address it. But thank you for the question. I believe it is one of the open areas where we can contribute, and not only contribute for India, but also possibly take it to the standards and also make it a contribution from India to the world as well. Thank you.
Any other question from audience? Please.
Hello. Good afternoon, sir. I am Shrikar from NIXI. So I'm working on internet resilience. Like my topic is internet resilience. I'm an undergraduate student, and you have mentioned about HAPS, that are high altitude performing systems.
Yeah.
So during my research, I have come to this conclusion that the LEO satellites, like the Starlink and stuff like that, they can even complement the traditional optical fibers and the broadband, and they can provide good connectivity to the rural areas. So how much HAPS can be used in enabling rural connectivity, as well as how much HAPS can perform in terms of resilience whenever there is an internet shutdown or an internet outage? So how much HAPS can help in this regard?
Okay. Excellent question. So basically what he has, let me paraphrase it. In the context of the non-terrestrial network, you have two choices. Today, the obvious choice would be the LEO satellites, Starlink, and that type. And why would you want to bring in a high-altitude platform station? HAPS or HIBS is a high-altitude IMT base station. So here is a quick response. The ability to hover over an area and provide what you call umbrella coverage, not the fundamental coverage, but the additional coverage can definitely be done by a LEO system as well as by a HAPS. The main difference is for LEO, you will need a constellation, which means that you must have a sufficient number of satellites, and these satellites must have inter-satellite links. And your visibility of the satellite is going to be for a very short period because it's a low Earth orbit satellite, and you're constantly being handed off. So basically, this is one which it's a problem that can be addressed and solved. But on the other hand, you have HAPS, better link budget, very, very little Doppler, and is more or less operating like a geostationary satellite. Now, if you say that, no, I still see advantages with the LEO, I would agree with you, you have a constellation, well and good, but if you have, for example, a natural disaster and you want to immediately restore coverage, I would say that HAPS would be an option. So basically, HAPS and LEO probably have their own roles, but both belong to the non-terrestrial network, and we will explore that for ubiquitous coverage. Thank you for the question.
Okay, so if there are, I see a small hand here.
Oh, sure.
Jain sir, I'm Rajesh Bodade. I'm representing Military College of Telecommunication Engineering, MCT Mao. Now, Professor Rao is aware we have the testbed of 5G, which is developed by the MCT, by the IIT Madras.
Yes.
And optimizing it and converting it to the defense band. We, after carrying out the test, validation and things, at one stage we come to know that there are major changes required in radio, RAN, and to extend core also to meet the specific requirement of the defense. Yes. Which certainly may be difficult once things has moved up, some had already made some progress. Certainly the commercial developers, players, especially the foreign players will not going to solve the problems of the defense. Right. Now in this scenario, when 6G mission has started, why not to include the representation of the defense into the forum so that certain requirements, certain frequency bands, the specific requirement of the defense can be incorporated right from the final in the specifications, maybe a mill version or a different version of the system, so that there are multiple requirements. Like we also wanted to have interoperability with our legacy network. Now we are talking about the non-terrestrial interoperability. I mean, connect with the non-terrestrial network. Right. Similarly, we want always to have that interconnectivity or interoperability with the legacy network, and of course, security aspects and what cyber resilience.
Resilience,
has been talked. So these aspects can be thought, at least thought. It may not be addressed completely, but to some extent. So my suggestion is actually in your team, certain defense representation should be there right from the beginning, so that things can,
Thank you for the comment. I agree with you. I think the forum in which we should address this is the Telecom Standards Development Society of India, TSDSI. I think the requirements of the defense should be brought into it. Definitely we can look at it. But just to answer your question, the public safety requirements, maybe to some extent, maybe not as stringent as defense, but to some extent have got similar requirements. And that is being addressed, even at the standardization level. So I believe that this should be taken up if we can take it up within India first and then outside. Thank you.
We are running slightly behind of time, so I would request if anybody else has got any other question, please take it up with Professor Koel Pillai outside the session. Sir, please don't come down. So again, a very big thanks from the organizers' behalf for delivering such an excellent lecture. So I request Dr. P. Hanumantarao, DG Sameer, to present a small memento as a token of thanks to Professor Koel Pillai. And I request Dr. Hanumantarao to be on the stage, please. So our next distinguished speaker is none other than Dr. P. Hanumantarao, DG Sameer. So I believe he has already been introduced in one or two sessions in the morning. So I'll just say two lines about him and that's all. He has received his PhD from Queen's University, Belfast, UK. After doing other studies in India, and he has been in the forefront of 5G and 6G research in the country. He has been a very, very active, he has taken very active part in the 5G testbed, indigenous 5G testbed, end-to-end solution developed in our country, and he is leading the 6G terahertz testbed, what was mentioned by Professor Koel Pillai in the country. So with this, I leave the stage to Dr. Rao to deliver his lecture.
Thanks, Ajit. You had an excellent introduction about what 5G, 6G, and how India is stationed there in taking 6G to the global platform. And as David mentioned, we've been part of the Bharat 6G Alliance. Probably we are one of the founding members, 14 of us. And with a great enthusiasm, we wrote the 6G vision document. And probably Samir was the first one in the country to receive the 6G project. It's around 70 plus crores awarded by Honorable Prime Minister during the launch of Bharat 6G vision document itself. And from there we made enough progress there and we built the solutions. So whatever I heard till now was the technology, how the technology is going to shape, what was the generations which have shown from typically analog systems starting from 1G and moving on to the digital systems from 3G onwards with the CDMA, 4G and 5G, and how 6G is going to reshape the way what you visualize the network as instead of just a communication, it's going to have the communication and sensing too, C and S. And how the couple of technologies which we envisage, IRS, Intelligent Referring Surfaces, or RIS, is going to completely change the deployment scenario because the frequency is going to move higher and higher. As per the 6G requirements, we expect it to go up to 7 gigahertz. And the propagation is much lesser at those frequencies, independent of the power what you pump, it cannot penetrate through the obstacles. Invariably, you are forced to bend the waves, or find a mechanism to redirect the beams. So that's a fundamental difference compared to all other generations and what 6G is going to look at it. So where RIS and or IRS going to come into picture. And second thing, as rightly mentioned, the introduction of the non-terrestrial networks, we call as NTNWs. It could be UAVs or HAPS, or probably there's some people say that mobile in the sky, or with a base station in the sky, or RRH in the sky, or the multiple names. Basically, we all fall under non-terrestrial network, and it has its own problems, as David mentioned. One is the shift; it's not going to be continuously stationary there, and how to visualize the entire network on connecting to again on the terrestrial network, integrated the non-terrestrial network, as we have the LEO satellites which an established deployment. And from there moving on to the communication network. We had the old satellite phones from the precursor to the existing approach of high altitude platforms. So I'll take you through what we build under these two technologies, both 5G and 6G. And specifically on 6G, the technology is what we mentioned about IRS. And there's another technology what we're working to increase the data rate is what's called orbital angular momentum, which is kind of a similar way what we operate in MIMO, the multi-input, multiple output there in 5G, and move on to the 6G. It becomes difficult there if it are going on to the large frequency, very high frequency in millimeter waves. Building radios at those frequencies is prohibitively expensive. Then we thought, why can't we attempt a kind of a newer technology, which of course exists there in photonics, or the optical domain rather, how to convert and exploit the technology of orbital angular momentum instead of having typically 2 degrees of polarization, which has vertical and horizontal, or 45 and minus 45, right-hand CP and left-hand CP, where you get only the 2 degrees of freedom, what has been envisaged till up to 5G. Then can we send the data on multiple modes, what we call as orbital angular modes, orbital angular momentum modes, OM modes, mode 0, mode 1, mode minus 1, mode 2, mode minus 2. But at the same time, each mode should be orthogonal to each other. Then only interference will not happen. So we did some interesting developments. We have a lot of simulations been done. We built a typical system at 28 gigahertz to operate the complete OAM solution on multiple modes, and we're building at 1 at 270 gigahertz too. I'll take you through basic introduction, what was the hype of the 5G. Till 4G, nobody bothered. Nobody knows what 4G is, and people are using the phone. But 5G, everybody in the country knows, everybody in the world knows what 5G is. Not that they understand 5G, but they talk about 5G. So I just want to bring the difference, what made that kind of hype for the 5G. Why it is different from all other previous generations.
What we built and the indigenous 5G testbed, which is a solution on its own, it is probably very few in the world have the entire stack. Living Ericsson, Nokia, and Samsung, Jetty, and Huawei, probably we are the only people who have the full stack. 4G we have stack from Tejas. And morning, Devashish was mentioning about from Jio having a core network, but still they don't have the full stack. So Samir, IT Madras, IT Kanpur, we are the people who have the entire stack in 5G, starting from the core network to the physical layer. So that's one which we transfer the technology to Tejas Networks, a Tata Consultancy Group, and they are expected to deploy the next generation solution 5G across the nation. Maybe 1.85 lakh towers or 2 lakh towers will have the solution. Of course, they build over that. Then how we leverage our research on 5G to 6G, and what are we doing in 6G projects. So that's kind of the outline what I'm going to take through. Typically, people have been talking about 4G, they've seen only one passive antenna on top of the tower. Initially we have the monopoles there, or include the handset on the base stations there. Then people start getting the typically directional antennas. Then they moved on to the array antennas. But still, there was never a multi-stream. They had a polarization diversity, they have the 45 and minus 45, but data was not transmitted over multiple streams. So there is a limitation on the bandwidth, and there is a limitation of the data what could be transmitted over up to 4G. And then the 5G came up. And the concept of MeitY was the one which introduced exclusively for 5G solution. And there were two frequencies till 4G there is only one frequency always. And 5G suddenly they came with the two frequencies. One is what's called FR1, other one is called FR2. FR1 refers to maybe frequency band 1 and FR2 refers to frequency band 2. Frequency band 1 is mostly for the deployment of the coverage. Frequency band 2, FR2 is meant for the large data. Of course, it didn't take up the way it's been promised. It's supposed to give 20 gigabits per second. Though there was demonstrations, but it became prohibitively expensive to create a handset at 26 and 28 gigahertz. Though there are deployments, few deployments in some parts of the world, but it never took it up, 28 gigahertz as a coverage solution. So the difference there, FR1 and FR2, FR1 we have 100 megahertz bandwidth, sitting around 3.45, 100 megahertz. People have 3.4, 3.6, 3.8, that's the range. Typically, it's, as per the standards, 100 megahertz bandwidth. When 100 megahertz bandwidth, and you see from each generation, 25 megahertz, 4 times bandwidth will increase. And data rate automatically comes in line with the bandwidth. Of course, adding up the other modulation layers and the MeitY techniques. So we had 25 megahertz, from 25 we went to the 100 megahertz. And data rate increases. And over and above, the newer technology, what we talked about is a beamforming. That's why it became completely different from the up to 4G. There's a word was never talked. Probably they used to tilt the beam a little bit, but there's never a beam forming, an active beam forming where I could to any extent, it can go to the 3D beam forming in the 5G. Typically, we can have multiple beams for the multiple users. One can have the data, one have the broadcasting data, one have the voice data, one have the digital data. So it can be configured the way you want it. So that's one thing made 5G unique, the beamforming, both the FR1 and FR2. FR1 was the MeitY system. Because we have only 100 megahertz bandwidth, we start applying the MeitY. 16 transmitters, 16 receivers, or 32 transmitters, 32 receivers, and went up to massive MeitY, 64T, 64R. That's kind of the largest deployment. We built one cloud, C-RAN antenna system, one of the world's largest one, 128T, 120R. So that's given to Hyderabad for their research and some kind of measurements they were doing about on C-RAN. So we built the solution of course, it works at 2.4 gigahertz, not on 5G band. So second band, as I said, FR2 is millimeter wave. We have 400 megahertz bandwidth. So we have a large bandwidth available at that place. So because we have a large bandwidth, you don't need a typically full-fledged MeitY system. Then we approach the problem, being high frequency, being expensive transceiver systems. MeitY, you need each antenna needs one independent channel. You need full RF chain, a transmitting chain and receive chain completely. And both ways, because your system is the bidirectional, you are transmitting and receiving, and the same thing should happen at the UE also, but they have a handset. So that was possible at 3.5 gigahertz, and start moving on to the millimeter wave band at 26, 28, and people go even 30 gigahertz bandwidth. That became expensive. building a transceiver system, unless otherwise an IC is made actively available at maybe half of the what is expected to have, 1/4 of the cost what they expected to launch there. So it didn't take up. Then we start approaching the problem, we have 400 megahertz bandwidth, you don't need a full-fledged MIMO. Then we approach the problem as hybrid MIMO. We have 2x2 MIMO, and within the single system, 28 gigahertz, we made an array. And array like 64 elements, then we went to 256 element array. Just making an array will not steer the beam. Then we convert it into a complete full-fledged phased array. Each 4 elements are being supported by a quad channel phase shifter, which in turn controls they have the transmit receive switch, which controls the beam, both the transmit mode and the receive mode. And adding 2 of them and the 2x2 configuration, 4 of them, we create the 2x2 MIMO. So basically within the single element, it's a full-fledged phased array, and 2x2 MIMO makes us a typical MIMO configuration what implemented at FR1. So we are combining both analog beamforming and the digital beamforming. That's why we call it as a hybrid MIMO. So that's what is deployed at, what we built at millimeter waves at 26 gigahertz. It's a fully functional system. This is one of the most interesting slides from Ericsson. It's been there almost for many, many years. Very interesting thing to understand why 5G has made a massive difference for the deployment scenarios, not from the user perspective. Look at the first one. You have 60/40/64R. Does it have laser? Okay, invisible. So we have 60/40/64R. On 60/40/64R, you have the high-raised buildings, and your intersite distance is less than 200 meters, between 200 and 500 meters. And we need to you are expected to cover the vertically, because there are multiple users there on elevation plane. So your beam has to be bidirectional. In sense, in elevation also we need the one kind of the beam width, and azimuth you need different of the beam width. So when you have to cover the large building, you start combining the elements in the elevation plane. Beam width becomes narrower, your coverage comes less, then you have to steer the beam both directions, both on elevation and azimuth. So how it is done? On elevation, we combine only 2 of those elements, and you get the large beam width of 30 degrees. I mean, it's a typical example. So you can cover the buildings where the intersite distance are 200 to 500 meters. And azimuth plane, we have the complete beamforming. So that was the way to address the high-rise buildings at short distance. But you don't have such high-rise buildings, you don't have skyscrapers, but you need to have the coverage more than 200 meters, 500 meters, going up to 1 kilometers, low to mid-rise buildings. Then we combine 4 of such elements, then 60/40/64R becomes 32/32R, beam width comes 15 degrees, so you get the gain, you get the range, and you start getting you don't need to cover, there is no building nearby, it's going the farther distance, there are not 2 high-rise buildings, then with 15 degrees you cover. Then you have a large distance, is more than 1 kilometer or so, is a launch site distance. Then we combine all the entire column, the vertical column, all the 8 elements are covered. Then typically the 60/40/64R becomes 16T16R. There are only 16 channels transmitter, 16 channel receive. It's basically is a dual polarized, that is 8 slant 45, 8 slant minus 45. Then you can cover your beam width becomes 8 degrees, then you can cover the large distance. And all this is done digitally. It's only the code. There is no change in the physical hardware. The single system, entire RRH, remote read ahead, it has the 60/40/64 configuration, and you configure digitally to address to the different kind of deployment scenarios. That's why we used to tell, at least whenever Professor Paul Raj used to come from Stanford, he is the one inventor of MIMO. He used to tell 5G is the fabric of the society. Depending on where you want to deploy, and it can be configured the way it's supposed to. But up to 4G, it is deployed and used. 5G can be reconfigured for the place where it's been deployed. So that's beauty which made 5G so much talked about. And for the user, they talked about large data, then then you say that your software, the programming, most of the kids get excited about using the games, and they say, PUBG or something, will that play on this mobile? Before buying the mobile, they say, will it support? And the way it is being projected, saying that you don't need to put the software on on the system itself because you have such a large data rates, your phone can be free, but still you can play the game without having any latency. That's where it is projected. So in that sense, it had a huge amount of the hype. As I said, quite much beamforming is possible. If you look at the first MIMO sectorization, I can have an azimuth and elevation, conventional beamforming in the horizontal direction only. Then you go to the 3D beamforming, basically for single user, I can have one dedicated beam. Then the same base station or RRH, what we call as RG node beam, I can have multiple beams for the multiple users, and you can, as I said, each color refers to one type of data. So I can create the multiple streams of the data and can address multiple users deployed spatially separated in 3D space. So that is the beauty of MIMO beamforming. That was practical because each element is having its own transmitter receiver, boils down to be a full-fledged digital beamforming. So with that background, we'll just take you through what we built. That is the basics why 5G was a hype, how the 5G made difference, because you heard entire generation shift from Professor David. So from there, one word we always carry from 5G, active and passive antennas to support the coverage, capacity and rollout needs. That's the one tagline we use for the deployment of the 5G, which wasn't practically possible there at 4G, up to 4G. So there's an antennas become active, and you have you combine both active and passive antennas, and one on a hybrid analog beamforming and one on the full-fledged digital beamforming. Typically, you see the configuration on a hybrid beamforming. You have a single RF chain, then upconvert there, or maybe the receive chain, you have the down conversion. We have 1:10 power divider, goes to the multiple number of antenna elements, and each is having a controlled amplitude and phase. And you combine few of such systems, and you make a digital beamforming. And you translate them into at the hardware side, you have 8x8 array, combine 4 of them. Each beam has, each 8x8 array has its own stream. I can create independently multiple beams, a single beam or multiple beam from the same stream, and address the multiple users. So that was what we built in the FR2. At FR1, yes, we did the complete digital beamforming. We have the data come from the baseband at 64 antenna system. Then we have the data aggregator FPGA, then divided into 4 segments, and we have 8 plus 8 plus 8. Then each of them has A to D and D to A. Then we have the radio transceiver for the per antenna system, and that is connected to each element, which is again dual polarized. And put together it is in a single box, and what we call as RRH. Another thing what just want to mention, till 4G you have the antennas carry only the RF signals. What comes from down is an RF cable and all the processing happening in the bottom of the tower. But if you see in 5G, all it is down converted. Down converted on that's why you don't call base station in 5G. I mean, don't call the antenna, you call RRH, remote radio head. There's a radio sitting on the top of the tower. So we have the N-channel radios, it could be 64 or 16, whatever the way you configure it. This radio sitting on the top of the tower, we down convert, do the bit processing depending upon what split you want to do, 7:2 or maybe the kind of industry standard. We followed 7:2. Then convert into the optical domain and bring the data through the optical fiber, do the remaining processing in the baseband, then to the core network. So that was the way, that's why it's called RRH. This is on millimeter wave. We have 4 channels as I mentioned, 8x8 is an array with a completely digital phase shifters. Combine them into 4 channels, millimeter transceiver system, and use the 2x2 MIMO. This is the first millimeter wave tile phase that are built in the country. And we were proud to say that Samir has built almost like 7-8 years back and fully functional there. Then we extended to some of the radar applications. Basically, radar on a tile, including FPGA. Everything into one PCB. We never had this technology in the country. We have plank technologies. From there, we moved to the tile technology. So we built in maybe 22, 23 by the time we have closed this. We have the full-fledged tile array configuration technology available on multiple frequency bands. Then we moved up there, tried to build the entire RFIC. Now you can see the solution. We used to procure these ICs for the TR module. Then from IIT Madras, we built the entire TR module itself, which which is working 26 gigahertz. It's a fully integrated indigenous solution for the complete tile. Then one of my PhD students, we did a interesting piece of work there. I think he's around there, Dr. Prasad here. So we started looking at how to generate the multiple beams when you don't have the multiple RF chains. Then he came up with the simple concept of using the typically classical equations of Skolnick, how to generate the multiple beams and linear array. Then we modified the basic concept and the equation, extended the planar array, then added a couple of extra, variables into the equation. We added the number of beams and the power of the beam, which was not there part of the original equation which existed. And then we created an equation which can calculate the weights, and you can have the choice of choosing the number of beams and where the beam should point and what's the power of the beam. So we have the two controls, beam pointing, number of beams, and power of the beam. So that was one of the major contributions from the thesis. And we had a couple of publications on top of it. And the advantage, what it does, I have two users. I can have equal power. You can see the first one at minus 20, plus 20 and minus 20. I can have two beams beamed up to the two users. Both are equal distance from the tower. Suppose there is a scenario where I have one user is closer, who is a D1, and the second user a D2, where D1 is closer to the tower. Then I can reduce the power which need to go to the user 1 so that I can pump the more power on the second beam so that I can get the coverage and better quality of service for both the users simultaneously. So that's it. Only the limitation here is it is the same data for the both users because I have single RF chain. You have the multiple RF chain digital beamforming. I can have the way I showed the 3D MIMO beamforming, that way slightly differs. Then from there, moving on, how much more time I have? 10 minutes, okay, fine. All right, these are some of the challenges still continues to be there in 6G. What we have them is integrated terrestrial and non-terrestrial networks. It's going to be a challenge. Though people talk independently non-terrestrial network, people talk independent terrestrial networks, and you want to combine terrestrial to non-terrestrial network, still the protocols, interfaces is a challenge. And over and above, both networks are not stationary. The people are moving there within the network. You need to provide, at least here we have the tower is stationary, user is moving. Now here a tower is stationary, user is moving, that network itself is moving, and over and above we have non-terrestrial network, and so much of handshake should happen. This is what David is mentioning. If you use HAPS, kind of a little better coverage compared to the LEO satellites. At each very less frequent time, you have more number of constellations. Handshaking has to happen from the ground antenna, which itself is a phased array. Continuously at a track, you know how the Starlink works. Get the satellite into the beam, focus it, follow the satellite, and the satellite goes away with the beam. Next satellite comes, what are the antenna you have at the house or maybe the top of the roof, it comes back and latches to the second satellite. Like that, continuously you come to within the viewing angle of the antenna what is deployed at the top of your house so that you get the coverage continuously. That's the way the typically Starlink works. So as Professor David mentioned, you need large constellation of the satellites to get the undisturbed coverage. And typically you won't have a disaster management system. You can just fly a drone and call it as a HAPS, or you can have a balloon, or you can have a UAV and generate an ad hoc network then and there itself so that it can address to the needs of that particular scenario, which is not practical from a conventional LEO-based network. Some of the topics which yet to be answered, integrated communication sensing, that's going to be the major topic which is going to come under 6G, as already mentioned. Then we have the distributed deterministic networks, because it's not going to be the same, and they're going to be heterogeneous also. So that is another technology, another challenge which 6G has to address. Then we have, of course, as usual, wherever you have a network, you have the security and AI, all that gets to come in the picture. Then you have the digital twins. Air interface technology is going to be much different. Previously, you have the direct link from the tower to the user. Suppose you are using an IRS. Now you have one more layer of connectivity. Then the air interface have changed. It probably start looking at those technologies in much different way, though there's enough level of papers and theory has been talked about IRS-enabled communication, but practically it need to be implemented with all the protocols. It's not been completely done. Now, of course, physical layer it can be easily handled. Then full duplex. Till now, all the systems what has been deployed up to 5G is a half duplex, and it's been talked about for the past 2 generations. It's going to be full duplex. It's not happened yet. We expect that in 6G probably we'll attack that full duplex problem and we'll address it. Then the transmission, yes, we are moving to the higher frequencies, the propagation models, channel models, both at 6 gigahertz and 7 gigahertz and terahertz bands need to be addressed. 2 technologies, what I mentioned, reconfigure intelligent surfaces, orbital angular momentum, then holographic imaging, where you will be able to get the complete immersive communication there, and you get the access, because you have a large amount of the data, multiple sensors, I can create the full-fledged holographic imaging and have the communication. Of course, terahertz technologies, there's one more area which people have been thinking that may work. This I'll skip it. As I said, this is the first system we built, a full-fledged phased array working at 26 gigahertz. You see, entirely integrated. I mean, you can apply for a strategic application, it's a radar in a board on a PCB, or a conventional, it's a tiled array. And why we call tiled array, you can go on adding it, you can increase the range, you can increase the capabilities of an antenna. And you have the independent control or phase control on each element. Then we had an opportunity to showcase to Honorable Prime Minister before 5G was launched itself, and to see the first 5G call made by our Honorable Minister. It's in 19th May 2022, and your 5G in India was launched in October in IMC. So we made the first 5G solution in the country, and of course, IIT Madras, Samir and IIT Kanpur was involved, IIT Bombay was involved in building the core network. Then we had an opportunity, of course, we have Professor Bodede here, and we were there at MCT MOW. We had an opportunity to meet Chief of Army Staff, explain them that how the 5G can revolutionize the solutions for Army. As he mentioned, there's much more to be done when you want to build the military band solutions in terms of the devices and how to make it resilient and rugged to be deployed there in the Army networks. So that's another challenge which you do. And this is the system what we deployed at MCT MOW, a full-fledged solution which has the 3 of such nodes, and including the core network and the baseband and full physical layer RRH has been deployed there. And it doesn't use any what you call service provider. It doesn't use Airtel, Jio or anybody's network. It's a self-sufficient network, just ignore the frequency. It's a standalone network. It doesn't depend on the user. It generates entire solution within. We call it a complete in a single box. Then we transfer the technology to 6G. I mean, say 5G technology to Tejas. I mean, it's now Tata's form there. We did only FR1 technology transfer. Now FR2 is yet to be deployed there, and they are building on it onto a solution. So skip it. Right. As you mentioned, what can make 6G different than 5G? Typically the data, and you write N applications, or hardly half an N of the N may be met or M of the N may be met. But one thing which is going to change from the conventional 4G, 5G to 6G is a integrated communication sensing, one of the major one. Other one is its network going to be intelligent. If you just map it, around 2010 we had up to 3 gigahertz bandwidth, the 4G. We have voice and mobile broadband. That is one of the big thing. People say, oh my goodness, you will see the internet itself on a mobile handset. That was a kind of amazing. People felt that. And that mobile broadband came there, and that what we called there around 2010 on 4G, we call as connected people. Then it came to 2010, then it became a connected things. Then we have the IoTs, and we have the URLLC, then MMTC, and we have all n number of range of application what we climbed, and Industry 4.0 and all put together, and we said that is connected things. Now what is the word used for the 6G? It's going to be connected intelligence. As I said, the device is going to be both for communication and sensing, and that will add value to the entire network. So that's where we're going to talk about the AI and sensing going to add up there, and we call that as by 2020, and frequencies may go up to terahertz, may not be deployable, and that what we call as connected intelligence. I'll skip it. As I mentioned, enough that what way 5G and 6G differ most as their terrestrial, non-terrestrial networks, higher frequency bands, and as usual, large data and sustainable deployment scenarios. These are our 16 or 14 founding members of 6G. It is mostly driven by industry, then IIT Madras, then Samir. Of course, they were the ministers that time. And we have Tejas Network and C-DAC, IIT Hyderabad. So there's a complete, the first founding members of 6G Alliance. Then we brought out the vision document, and it was announced there on 22nd March 2021 at New Delhi. Along with it, 6G testbed was launched. Launched means the 6G testbed was given. This is the first project to take off there on hardware side. Before that, as Professor David mentioned, IIT Madras and around 18 institutes were working on standardization for 6G. This is the first project on 6G under the funding which has been announced there. Then we started doing the research there on terahertz range. That time it was felt that terahertz is going to be one of the deployment scenario. And as the journey started, we realized that deployment is going to be more than 7 gigahertz, and we started reconfiguring the entire solution into the 7 gigahertz deployment scenarios. And this is one thing why everybody want to know what going to the frequency of 6G. Everybody jumps on 6G. What is the frequency of 6G? Yes, 6G has a range of frequencies starting from like we say DC to light. It's like that up to 300 gigahertz and plus. Still people say up to terahertz, it's a 6G band. But deployable, the way it's taking shape in terms of the standards on the meetings you attend to and understand that radio is going to be there in deployment scenario, mostly could be around 7 gigahertz and 6 and 7 gigahertz on centimeter range, that the way the deployment will happen. Terahertz could be the backhaul or the point-to-point communication may come or may not come. But that's one of the areas where, but the device is going to be, has dual application both for strategic and civilian applications also. Samir is doing 2 major projects implementing both terahertz technologies with orbital angular momentum and AI-driven IRS-enabled communication, and both at 140 gigahertz and 7 gigahertz, and other one at 270 gigahertz. One is funded by our own ministry, Ministry of Electronic Information Technology, other one is by DOT. I will show you what OAM is about. This is a wireless thing, what we are going to establish. You want to visualize what OAM, it's kind of a rough analogy. You stand on any part of the earth, your motion is over the axis is going to be circle, but go around the sun. Earth is going out of the sun, but your motion with respect to is a circle. So that what we call as a spin angular momentum. That is a circle polarization. Vector is rotating in a circle, but it's in a spin. Over the axis only is rotating. There is no translation motion. That's what we call as a spin angular momentum. In orbital angular momentum, it's still the vector is going in circle, but there is a shift in the wavefront. Because there is a shift, it's not over the axis, it's been tilted, I can create theoretically infinite number of modes, and I can take the modes which are orthogonal to each other. That's OAM, orbital angular momentum. That refers to you standing on the earth, you become, your axis on which you are rotating becomes spin angular momentum. With respect to sun, you see your position is continuously changing, that becomes orbital angular momentum. That is way to visualize what orbital angular momentum is. And you can see the modes, how it can be generated. This is the first demo probably in the world on 270 gigahertz, live demo, not post-processing, directly transmitted, and we demonstrated 2024, 6.4 gigabits per second data on 270 gigahertz. So that is one of the major achievement what we have achieved at IIT Madras and Samir. So we did the data generated. We generated the data using OFDM there, then upconverted to some of the IF bands, then final upconversion. Yes, the front end is at this stage, which I'd say that probably 60%, 65% indigenization, where the final front end is bought out item. Now, today we have 75% indigenization. By end of year, or maybe the first quarter of next year, we'll have 85 to 90% full-fledged terahertz subsystems available in the country as a catalog item. Yeah. Then you can see all those subsystems are built in sub-terahertz at 270 gigahertz, 140 gigahertz. We build the antennas, we have build the filters, then we have the waveguide extenders and first level upconversion, and we have an IRS sitting there, and we have the 2 links at 270 and 140 gigahertz. They were live links which was demonstrated. And this we have father of DSL. Everybody used the DSL modem. He was excited to see what we built there. He's from, is John F. Cleoff from Stanford University. Of course, we have secretaries and from PSA. And we launched some of our terahertz components during IMC. This is the way we did, as I said, part of the PhD of Dr. Prasad. We did the multiple beams, and we can scan the beams, point the beams, and change the beam shape and the size. Then we can control the beams to create the contour, or we can create the null on a specific location, not have the coverage within the contour instead of switching off the entire satellite communication or maybe the entire base station. This can be created. I'll skip all this stuff. This is IRS. How the IRS differs from the phased array? I have another 5 minutes or over 5 minutes. How the IRS differs is, in the phased array you have, it's more on it could be on a transmitting mode or receiving mode. You have the phase shifter below each element, control the amount of the phase being fed to each element. And you create the progressive phase and steer the beam, what are the angle, both elevation and azimuth or 3D beam forming. You have the full control on each element phase. But going ahead on a large arrays, you need to have some room size array. It's going to be prohibitively expensive. And business works on the deployment should be as cost effective as possible. IRS is the technology. You can see that green and yellow, that refers to two states. So when it is green, the antenna element is added with a device which is forward biased. So it has an impedance ZX and or ZF, you call forward biased. Antenna element is ZA, both added. Together it reflects an amount of the phase. Then reverse biased. My antenna element impedance remains a ZA plus ZR, which has a different kind of impedance, reflects a different phase. We optimize the entire antenna, taking the device, loading the antenna with the device, and we control the phases 0 and 180. When you have the two states of the phase, and we map this entire array, and we are able to steer the beam. I'll show how it works. Then you have to one stage up, then we created the 4 of such things, use the vector instead of the pin diode. You see the each color coding. Red refers to 180 degrees, blue refers to 270 degrees, green refers to 90, black refers to 0. They refers to a typical amount of the voltage what you apply on the vector. When that amount of the vector is, bias is applied on the vector provides a specific impedance added onto the antenna element. When signal falls, it reflects with a specific phase. That phase is 0 phase. So we optimize it, and this is a typical measurement what we created at Samir, Calcutta. And assume that signal is falling at a specific angle, and you want to steer the beam to a desired direction. Take a first case. You see the entire frame. Signal is falling at minus 30 degrees on a surface. I can create the pattern like that. Basically, there's a voltages what I'm applying on those elements on 20 by 12 array. Beam steers to minus 20, then minus 10, 0. Basically, on the fly, we can create the weights and steer the beam. It's a reflected beam. So it's a much different from the conventional phased array. That's why it's called reflecting surface. Then add intelligence on it, identify where the user, and steer the beam on its own to the user. Then it becomes IRS or reconfigure intelligence surface. We build that. It's the measurement done. Then this taking about OAM. So we have all the modulations and frequencies, MIMO. This is OAM. You have OAM mode 1. You just keep looking at the mode, how it's moving. Then we have the mode 2. Then mode 3, and combine all of them. See, they don't interfere each other. And put them in a single stream, then take multiple of such streams, add them up, spatially separated. Then you have the full-fledged. You have the 3 modes on it, then 4 such channels, you have the data. That's why we propose to get the 100 Gbps data, planning to demonstrate by October IMC, hopefully. Then we build the filters, thanks to one of our young researchers there at Samir, Calcutta. We built at 140 gigahertz, built 270 gigahertz. See the passband performance, hardly like 0.25 dB. And building a filter at that frequency and having such a low insertion loss is phenomenal. So he's around, his name is Dhrubodas, probably somebody is interested there. You can talk to him and discuss about these filters. We dealt one at 287 gigahertz also. This is a measured data. And we have the full system. And we have the test jigs, everything is in-house. Then the OM antennas, we build the OM antenna on, there is two concepts called uniform circular array, where you control the phases so that beam can be split into mode 1, mode +1, -1. And you generate the modes. There's other concept called spiral plate. Depending upon the what kind of the configuration on a spiral plate, you can change the what mode you generate. And these are also being fabricated. Maybe in a month's time, we'll have the measurement up. The multiple modes. So I'll stop them. Thank you.
So we thank Dr. Rao for taking us through the journey, India's journey for development of indigenous 5G technology and how we are traveling in the 6G domain. So we just have enough time to take one or two questions. So if there is any question from audience, we can take just one or two. Okay. So if there are no other questions, I'll just request you to be there. I'll request Dr. Murugan to present a memento on behalf of the organizers. Dr. Murugan. Program Director Samir Chennai. It's already there. No, piche somebody is there. It's not there? Okay, fine. There has been a miscommunication to me. It's okay. No, it's not bad. Dr. Murugan got introduced. Okay, so I thank the audience. So let us break for the high tea. Just for the information, we have a stall down below from Sameer's side where you can go and see some of the 5G, 6G technologies which has been indigenously developed and talk to the people who have developed it, to the researchers, scientists. And if your curiosity is somehow awakened by these engaging talks, you can have some more insight. Thank you.